Welcome back, guys. I hope all of you will be fine. So from today we are starting chapter 5, which is related to some discrete probability distributions, in which we will discuss some very important discrete random variables and discrete probability distributions, which has significant role in your lives and all day-to-day activities. Okay, so let us first start question 5.1. This is the first question of the exercise. So let us first see that what is this statement. A random variable x that assumes the values x1, x2 up to xk is called a discrete uniform random variable if its probability mass function is fx is equal to 1 by k, means the number of random variables are here has the same probability, and that is 1 by k for all of x1, x2 up to xk and 0 otherwise. Find the mean and variance of x. Okay, so let us first see the solution of it. Okay, so in solving it, what can we see if we have the random variables here? This is what this is. These are basically the random variables, and these are the probabilities these has. So each and every one of it will have similar probability. Okay, we can see here that, and these would be up to here x of k. Okay, these are x naught, x1, x2 up to x of k, and each one here, if these are basically k number of variables, so the probability here will be 1 by k. Okay, one of its example is the die in which all elements are basically what? Let me first draw it. Okay, so here we have either we will have 1, 2, 3, 4, 5 and 6. Okay, so all of them will have same probability. Okay, because these are equiprobable, and this probability is what? This is 1 by 6, because here you can see that this is x of k, and here the sixth item is here the same probability as we have here, and these are basically the uniform probability distributions. Okay, so I hope you have got my point that what is mean by the uniform probability distribution. So what do we have to do? We have to find mean and variance of x of k, and it is very clear here that in order to find the mean of it here, what do I have to do? So I have to add all these items together, and what do I have to do? I have to divide them over the total number of items. So here we can do what? It would be x1 plus x2 plus x3 plus x4 plus x5 plus x6, okay, divided by the number of items, which are 6. So this is what? This can be the mean of it. Okay, this will be the mean of it. Similarly, for the generic terms here, what we can do here is that here the mean of it will be x1 plus x2 plus x of 3 plus x4 up to and until x of k divided by the k. Okay, sorry, this is k divided by k, or we can also write it what? We can also write it like from I equal to 1 up to k x of I divided by k, or 1 by k is outside of it, and then I have to add these items together from 1 to k. So this is what? This is basically the mean of the random variable which we have. Okay, similarly, if you want to find out the variance of it, the similar equation which we have seen previously would be what? That would be from it as well, it will be 1 by k, and from I equal to 1 up to k I have to take each item, and from it I have to subtract the mean and square it. Okay, this is what? This is basically the variance of the items which we have. Okay, so this is what? This is the solution of question 5.1, and this is basically the essence of the uniform random variable or uniform probability distribution which I have described in this question. Okay, so that is basically the solution of question 5.1. Let us proceed to question 5.3 because this is also relevant to the uniform random variable. So let us go through it. So question 5.3, an employee is selected from a staff of 10 to supervise a certain project by selecting a tag at random from a box containing 10 tags numbered 1 to 10. Okay, so a box we have in which we have some tags. Let me represent them with this similar tags which are numbered from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same size and same tags, and on each of one we have numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and here on it we have 10. Okay. Find the formula for the probability distribution of x representing the number on the tag that is drawn. Okay, so these are placed inside this box and therefore each has a similar size, similar probability. So that's what this is, what this basically represents, the uniform probability distribution. What is the probability that the number is drawn less than 4? Okay, so the probability here of drawing each item is k, and this is what, this is 1 by k. The k here is 10, so therefore the probability here for this case is 1 by 10. So each item, the probability of each item here is 1 by 10. Similarly, what is the probability that the number is drawn is less than 4? So I have to find the probability that the number drawn is less than 4. So less than 4 means the probability that x equal to 1, or probability that x is equal to 2, or the probability that x is equal to 3. So 1, 2, 3 tags are selected. So what is the probability that x is equal to 1? That is 1 by 10, because all of them are equiprobable, and that is the uniform probability distribution. Similarly here, what is the probability that x equal to 2? That is also 1 by 10. And what is the probability that x is equal to 3? This is also 10. So adding them all together, what will we get? This will be 3 by 10, and that is basically the solution of question 5.3. So you have seen that how to find out the probabilities in the uniform random variables, and these two questions closely relevant with the uniform probability distributions. Okay, so if you have any question, you can ask me in the comment box. That's it for today, and I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. So this is question 5.2, and today we are going to solve it. So the statement of this question is 12 people are given two identical speakers which they are asked to listen to for differences, if any. Suppose that these people answer simply by guessing. Find the probability that 3 people claim to have heard a difference between the two speakers. Okay, so here in this type of questions, what do you have to do? What will be the approach, and how would you solve these type of questions? First of all, you have to write the given data. So in given data, we have to write the total number of people first. So let me denote the total number of people with n. So n is 12. Okay, and they have to check two identical speakers to see that whether there is a difference or not. Okay, so what do they have to do? They have to see that whether these are identical, okay, or different. Either the two would be identical or different. Okay, and there is nothing given about that how much it is probable that the two speakers will be identical or different. So therefore they are equally probable. Okay, so therefore the identical has the probability 1 by 2, and different has a chance of 1 by 2 as well. Okay, so let me represent the difference with Q and identical with P. And how did we get it? We have got it by q is equal to 1 minus p, because this is a binary case in which we have only two cases, either those would be identical or different. Okay, and we have to find the probability that three people claim to have heard a difference between the two speakers. So I have to find the case in which the people or the persons are three and there are three votes which see that the two speakers are different. Okay, so therefore we have to see the three cases in which the speakers are told to be different. Okay, so these type of questions in which we have the binary operations. Okay, so these are basically what, let me represent them with this color. So we have the binary operations or two operations. So these are basically the trials which are called Bernoulli trials. Okay, we have a trial of either 1 or 0 or true or false or good or bad. Okay, so each of the case here represents what, that is basically the Bernoulli trial, and one of the foremost case for it is basically the coin tossing. Okay, in which we can either have heads or tail. So this is what, this is a single Bernoulli trial, single Bernoulli trial, single Bernoulli trial, and single Bernoulli trial. Okay, here we can see that we have three cases in which we have to see that there is a difference between the speakers. Okay, so we have here three Bernoulli trials. Okay, also we can see that we are given the chance of each trial here as well. So these type of trials in which the total trials are given. Okay, total n are given, and we have to see the cases k for which either it is true or false, or either it is good or bad, or either it is different or identical. So these type of trials basically moves into what, this is basically the case of binomial probability. Okay, so now we have what, this is the binomial probability, and this binomial is based on bi and then nomial. Okay, so this bi is for what, this is for 2 and this is for the cases. Okay, so two cases encounters with the binomial. If we have multiple cases, so that would be what, here there we would have to represent this bi with multi, and that would be nomial. We will also try to solve questions for multinomial as well, but this question, which is the case of the binomial probability law, we had encountered it here and we are going to solve it now here. Okay, so as we have here all these cases, so let me remove it and let me see that how to solve these type of questions. So we know the formula for the binomial probability law, and that is what, that is basically the, if we want to find out the probability that the items or the elements we have would be k equal to small k, it would be what, it will be the n choose k with the probability of it and then k and then 1 minus p n minus k. Okay, so here we have the probability of the differences. So this is what, this differences probability is basically p, we have to see the different items. So therefore here I want to find out the probability that we have three persons who are saying that the speakers are different. So therefore I want to find out the probability that k equal to 3. Let me put these values here. N is how much, that is 12, this is 3. Okay, p is what, this is 1 by 2. Okay, and k is 3, and also 1 minus p is how much, that is again 1 by 2, and n minus k, 12 minus 3 is 9. Okay, so let me find it out. Opening it, I will get 12 factorial divided by 3 factorial, and 12 minus 3 is 9 factorial. Okay, combining them two, I will get 1 over 2, 12. Okay, so let me move down somehow. So now what I will get, this is 12, 11, 10 into 9 factorial divided by 3 into 2 into 1 into 9 factorial. Okay, these two will cancel out, and here it is 1 over 2 raised to power 12. Okay, looking at these things here, 3, 4, 12, 2, 5, 10, and finding it out, I will get 220 multiplied by 1 over 2 raised to power 12. Okay, or 220 divided by 2 raised to power 12 is 4096, and dividing it over 8, what I will get, it would be 0.0537, and that is what, that is basically the solution of the question 5.2. Okay, so that's it for today, in which we have seen that how to see that whether a problem at hand is of binomial or Bernoulli or of uniform distribution. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 5.4 of chapter 5, and the statement of this question is, in a certain city district, the need for money to buy drugs is stated as the reason for 75% of all the thefts. Okay, so if all the thefts have been carried out, so there is a 75% chance that the thieves has stolen all the stuff due to their drug addiction. Okay, so find the probability that among the next 5 theft cases reported in this city, exactly 2 resulted from the need for money to buy drugs. Okay, and B is at most 3 resulted from the need for money to buy drugs. So before going into the detail of this solution, let me first write that and see that which type of probability is that and how can we find it out. Okay, so first of all, let me see that what is given. So in the given data, we have been given that out of all the thefts, we have the probability that a thief is a drug addicted is 0.75. Okay, this is the probability. So the probability of the drug addiction is 0.75, and the probability that he is not a drug addict would be Q is equal to 1 minus P, so it would be 1 minus 0.75, so it would be 0.25. Okay, so this is the given data. After finding it out, we have 5 theft cases, and out of those 5 cases, okay, let me see that we have 1, 2, 3, 4, 5. So out of all these 5, we have to see that these are the theft cases, and out of these we have to see that either he has been stealing the stuff for buying drugs, so either it can be for the drug or no drug, it can also be drug or no drug. Okay, so here we can have drug or no drug, which is basically what, which is a binary process which can be either 1 or 0, and this binary process or this trial for true, false, 1, 0 and all of these things is basically the Bernoulli trial. Okay, and I have told you previously that the combinations of the different Bernoulli trials give me what? It give me the binomial probability. Okay, so it is clear now here that in order to find here exactly 2 cases in which the money is stolen to buy drugs. Okay, so here what do we have to find out? We have to find here the probability that the 2 cases are reported for which the money has been stolen to buy drugs, and for them the total number of the theft cases were what? Those were 5. Okay, so this is what, this is the case of the binomial probability, and I have told you that why is it binomial probability. So let me solve it, and I have previously told you that to find the probability of any, what do we have to do? We will have here n choose k, p of k, and 1 minus p or q, n minus k. Okay, let me put all these values here for this case. So here it will be pk is equal to 2. Okay, here n is 5, k is 2, p is 0.75, 0.75, and here k is 2, and 1 minus p is q basically. So 0.25, and 5 minus 3 is cube. Okay, so let me find it out, and finding it out, it would be 5 factorial divided by 2 factorial, and 5 minus 2 is 3 factorial, multiplied by 0.75 and square, and 0.25 cube. What it would be? It would be 0.00879. Okay, and at the end, when we will calculate it, okay, when we will calculate this one, the answer of it will be what? The answer of it will be 0.0879, and that is what? That is the solution of part A of question 5.4. Okay, so the solution of part A is given, and that is what the probability that we will have two theft cases for buying drugs was 0.0879. Okay, so that is the solution for part A. Let me proceed to part B of this question, and let me move down somehow for this one. Okay, so the data will remain the same, and we have to find that at most 3 resulted from the need for money to buy drugs. Okay, so at most 3 resulted means what we have here? We want to find out the probability that the k value of k is less than or equal to 3. Okay, so the value will not exceed 3, so it can be what? It will have two possibilities. The first possibility will be we have to find out all the values which are less than 3, so it will be the k equal to 0, or k equal to 1, or k equal to 2, or k equal to 3. This is the first possibility that we have to carry out all these calculations to find out the probability that k is less than or equal to 3. Similarly, we can also formulate another mathematical equation in which we will have this k less than or equal to 3, and that would be 1 minus the probability that k is greater than 3. Okay, so here let me expand this formula. So I will have here 1 minus this probability of k is greater than 3 will not include 3, so therefore the probability that k is equal to 4, or the probability that k is equal to 5, because the maximum value here of n is 5. Okay, so here you have to carry out these two calculations, and then you have to subtract, add them, and then subtract them from 1. So from these two cases you have to see that whichever is feasible for you to carry out the calculation, the answer of both of them will be similar. Okay, both of the equations will give you the similar answer, but the thing here is that you have to make these things easier for you, and you have to use your common sense to see that which is better for you. So you can very easily see that this second formula is basically using the two combinatorial formulas, so therefore it is easy for me to carry out this one. So let me do it. So 1 minus this one is here, and for k equal to 4 I will have here 5 choose 4. Okay, and the probabilities will remain the same. It will be 0.75 for p, and here it will be 4, and also 0.25, which is 1 minus 0.75, it will be 5 minus 4, so 5 minus 4, which is basically 1. Similarly, for the second term here I will have here 5 choose 5, here it will be 0.75, and here it will be 5, and also 0.25, and 5 minus 5 here I will have. Okay, so let me move down somehow here as well to see the solution of it. So here we will have what? This is the probability that k is less than or equal to 3. Okay, so here we will have 1 minus, this will be 5 factorial divided by 4 factorial into 5 minus 4 is 1 factorial, and here multiplying with these terms, this will be what? It will be 0.079. okay, combining them both, because 0.25 and raised to power 1. Similarly here I will have 5 factorial divided by 5 factorial into 0 factorial, and multiplying these terms, because it will become 0, and anything raised to power 0 is 1, so it will be what? It will be 1, and here it will be 5 factor 5, these two will cancel out, and here we will have 0.237. okay, so here it is what we have. So now let me have here 1 minus, here multiplying it, I will get 5 multiplied by 0.079, so it will be what? It will be 0.395 plus 0.237. okay, so carrying it out, adding them together, and then subtracting it from 1, what I will get? Here the answer of it will be 0.3672. okay, and that is what? That is basically the solution of part B of my question. okay, so in this part of question you have seen that how to formulate the strategy to use minimum calculation to reach to the answer of the any part of the question which is related to the binomial probability by using the probability theorem or axioms of the probability. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So we have started chapter 5 and we were discussing the binomial probability theorem or binomial distributions. So today we are going to solve question 5.5 and 5.6, which are closely relevant with each other, and both of them are basically the problems of the binomial probability distribution. So let us first go through question 5.5, and the statement of it is, according to chemical engineering progress, approximately 30% of all pipework failures in chemical plants are caused by operator error. okay, so this is basically the probability of the operator error. So let me write the given data as well. So the given data, this is 5.5, and for 5.5 the given data is what? The probability of the operator error is probability of error, or let me represent it with P. So P is 0.3, which is 30%, and therefore the probability that the pipe failures are not due to the operator error are Q, and that is 1 minus P. So 1 minus P is 0.7. okay, so you have to keep it in your mind that this is the probability of the failures in chemical plants due to operator error, and this is the failures in the chemical plant which are not due to the operator errors. okay, so let us go through the questions. What is the probability that out of the next 20 pipe work failures, at least 10 are due to the operator error? okay, so what do we have to find out? We have to find out the probability that total pipe works are 20, so it means that the n here are, let me remove it first, the number of total pipework failures are 20, and out of these 20, at least 10 are due to operator error, or k is greater or equal to 10. okay, so what do we have to find out? We have to find out the probability that k is greater or equal to 10, and this would be what? We can see that this would be from 10, probability that k equal to 10, okay, up to what? Up to the probability that k equal to 20. Okay, we have to find out all these probabilities. Similarly, we can also do it by another formula as well, and that would be 1 minus the probability that k is less than 10. Okay, so after finding them out, we can insert all these values here, and we will see that the output of it will be the values which we have to find out. Okay, so let me use this formula. So here, by using this formula, what will I have here? I will have 1 minus pk is less than 10. So therefore I have to use all these values from 0 to 9. So therefore we will have here k equal to 0 up to 9, and here we have to use the binomial probability law. Here would be n to k. Okay, and the probability of it, and this would be 0.3 k. Okay, and also here 0.7 n minus k. Okay, so here we will have it. Let me put all these values, because the value of n will remain the same here. So let me put the value of n here, and n is 20. So 20 here, okay, and 20 here as well. Okay, so we have to find them out, all finding them and then adding them together. The output of it will be what? 0.0480. Okay, so that is what? That is basically the solution of part A of my question. Similarly, in part B of question, what is the probability that no more than 4 out of 20 such failures are due to the operator error? Which means that in part B, I have to find out the probability that no more than 4 out of 20 such failures are due to the operator error. No more than 4 means k is less than or equal to 4. Okay, which means here I will have all the values of k from 0 up to what? Up to the probability that k is equal to 4. Okay, so here it will be what? It will be again the same formula, but here now the values are from 0 to 4. So here it will be k equal to 0 up to 4. Okay, and here n is 20. Okay, this is k, and the probabilities here will remain the same, 0.3. Okay, this is k, and also 0.7, and n minus k, which is 20 minus k. Okay, so that is what, after finding it out, okay, all putting all the values of k here, what will we get? We will get the output of it, and this would be what? Let me move down somehow. So moving down somehow, what will we get here? The answer of it will be 0.2375. Okay, so that is what? That is the solution of part B of my question. Okay, in part C, we have to find that suppose for a particular plant that out of the random samples of 20 such failures, exactly 5 are due to the operator error. Okay, so let us first find that what is the probability that exactly 5 are due to the operator error, and after it we have to see that whether those are basically 30% figure stated above applies to this plant or not. Okay, so let us first find the probability that exactly 5 are due to the operator error out of these 20. So here again, by using here the probability that k is equal to what? 5. Okay, this is a single value here. So using the binomial theorem here, for 20 choose k. Okay, and here 0.3, and the value of k here is 5, and 0.7, the value of k is n minus k, so that would be 15. So finding it out, what I will get here, the answer of it will be 0.1789. okay, which is what? You can see that this value is less than the value which is given, okay, here 30%. So it means this value is basically the viable value, and it applies to this plant as well. Okay, so that is what? That is basically the solution of question 5.5. okay, let us move to question 5.6 and see that what is it asking us. According to a survey by the Administrative Management Society, 1/2 of US companies give employees 4 weeks of vacation after they have been with the company for 15 years. Okay, so there are basically one half of the US companies which give the vacation to the employees which are with them for 15 years. Find the probability that among 6 companies surveys at random, the number that gives employee 4 weeks of vacation after 15 years of employment is anywhere from 2 to 5 and fewer than 3. Okay, so first of all, let me see that what is here the given data. This is question 5.6, and in given data, what should be the probability? The probability will be here either the company gives vacation to its employees or not. So here, therefore, the probability that a company gives its employees the vacation, okay, and that is 1/2, so it would be 0.5. Okay, what is the probability that a random company in the US will give the vacation to the employees which are for 15 years is 0.5, and the companies which do not give the vacation is again 1 minus 0.5, so it would be 0.5 here as well. Okay, so out of it, what do we have to find out? If 6 companies surveyed at random, okay, so which means n is 6, and we have to find out of them that the number that given employees 4 weeks of vacation after 15 year employment is anywhere from 2 to 6. So means, what do I have to find out in part A? I have to find out the probability of k that is greater or equal to 2 and less than or equal to 5. Okay, so I have to find out. How can we find it out? It can be found out by using the same formulation, that I will have the probability that k is equal to 2 up to what? Up to the k is equal to 5. Okay, so let me apply the same formulation as we did here. So let me start here, k from 2 up to 5. Okay, and n is here 6 due to the formula which I have stated earlier, and that is basically the formula for the binomial probability distribution. So 6 and here k. Okay, and the probability here is 0.5 of the vacation, so here 0.5 k and also 0.5 n minus k, so it would be 6 minus k. Okay, so that is what, that is basically the formulation, and here in order to find it out, we have to find all these values, and after finding them out, what will I get here? The values, you have to calculate them, and here the answer of it will be given here. Okay, similarly, in another part of it, we have to find that the companies which give the vacation are fewer than 6. Okay, so fewer than 6 means the probability that k is less than 3. Okay, which means here the companies will be from 0 up to 2, because 3 doesn't lie within this range. So therefore, all these value will be here, due to this will be 6 k. Okay, and the probability is 0.5, and it would be here what? It will be k and again 0.5, which is q. Okay, this q, and it would be 6 minus k as well. Okay, so you have to find these values here as well, and this will give you the probability of the question 5.6 part B. Okay, similarly, this is the solution of what? This is solution of part A. So that's it for today, in which we have seen the application of binomial probability theorem for a variety of applications which we have here. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is chapter 5, and today we are going to talk about question 5.7, 5.8 and 5.9. So these 3 questions are closely relevant with the binomial distribution, and these are relevant with each other, so that's why we have been covering it in a single video. So let us talk about question 5.7 first, and the statement of it is, one prominent physician claims that 70% of those with lung cancer are chain smokers. Okay, so all the patients which have a lung cancer are 70% of them are basically the chain smokers. If this assertion is correct, so part A of it, find the probability that of 10 such patients recently admitted to a hospital, fewer than half are chain smoker. Okay, so let us first see the solution of it, and we can very clearly see that this question is again based on the Bernoulli trials, and certain Bernoulli trials in which there are basically 10 patients or 10 trials, and out of them we have to see that fewer than half are chain smokers or fewer than half of them are basically true. Okay, so that is basically true or false. True means that a person who has a lung cancer is basically a chain smoker, and false is that a person who has a lung cancer is not a chain smoker. Okay, so how many of the trials we will have here in part A of it? We will have n equal to 10. Okay, and the probability that out of the all lung cancer patients, the chain smokers are basically 70%, so the probability here would be 0.7. okay, what do we have to find out in part A? We have to find that fewer than half are chain smokers, or half of this is 10, so we have to find the probability that k is less than 5, which is basically the probability that k is less than or equal to 4. okay, so here we have to see that what is the probability that fewer than half are basically the chain smokers. So how can we do it? By using the binomial probability law, we have to write here the total number of trials or total number of patients, and here k is basically the number of the patients out of them which has the lung cancer, and then we have to use here the probability of it, which is k, and then 1 minus p and minus k. okay, here we can see that we have here the number of patients who has basically the lung cancer, so this is a separate formula for a single item, but here as we have been doing it for different items, so here we will have here probability that k is less than or equal to 4. It will be from p k equal to 0, all the values which corresponds with this condition would be here, and also probability that k is equal to 1 plus probability that k is equal to 2 plus probability that k is equal to 3, and also the probability that k is equal to 4. okay, so these all values are basically corresponds with these values. Here we have to see that here I have to put all these values which will be here, so putting them here, what will I get here? I can cumulatively write them here as well, k equal to 0 up to k equal to 4 here, and choose k, probability of k, and 1 minus p and minus k. okay, writing these values here, what I will get from k equal to 0 up to 4. okay, and is what? N is 10, and here the values of k will be here, and p is 0.7, 0.7k, and 1 minus p is 0.3, and here it would be 10 minus k. okay, so taking all these values for all of them, which is here, 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 and here, you have to find them all by using this formula, okay, which is cumulatively like this one, and then putting them here, adding them together, you will get the answer of this question, which is part A. I'm not going to write the answer of it. You have to calculate it yourself, and you will see that the answer of it will be the same as it has been given in the answers of the book. Similarly, in part B of it, find the probability that 20 of such patients recently admitted to a hospital, fewer than half are chain smokers. Okay, so the condition here has been changed. Let me move somehow downwards, and here the condition is, this is part B, and here we can see that the number of patients are now 20, and we have to see the probability that fewer than half are chain smokers, so fewer than half here is 10, so here k is less than 10, or it would be probability that k is less than or equal to 9. okay, in order to find it out, again we will have probability of k is less than or equal to 9, so this would be from k equal to 0 plus k equal to 1, okay, up to what? Up to the probability that k equal to 9. Again using the same formula for which k is equal to 0 up to 9. Here we will have n choose k, so n is 20. This is k now. Probability will remain the same, which is 0.7, and it is k, and 1 minus 0.7 is 0.3. So n minus k, 20 minus k. Finding them all, what you will get? You will get the answer of part B, and here you will have to use this formula for all of these items and then add them together. You will get the answer of it. Okay, so that is the solution of part B. And you have been seeing that we have been using the binomial probability law, and it is very handy in such type of question which I have told you that how to find out, in which we have the number of Bernoulli trials and you have to find out the certain sequences in which this condition is true or false. Okay, so that is basically the solution of part B of mine. Now let us move to question 5.8, and the statement of it is, according to a study published by a group of University of Massachusetts sociologists, approximately 60% of the Valium users in the state of Massachusetts first took Valium for psychological problems. Find the probability that among the next 8 users from this state who are interviewed, exactly 3 began taking Valium for psychological problems, and at least 5 began taking Valium for problems that were not psychological. Okay, so first of all you have to see the probability that what is the probability that the Valium users were having the psychological problems or using the Valium for the psychological problems, and that is basically what this is 60%, which is 0.6. okay, and the total number of users which have been used for the trials are basically 8, so n will be equal to 8. okay, so the part A of it, on the basis of it, on part A of it, we have to see that exactly 3 began taking Valium for psychological problems. So I want to find the probability that k is equal to 3. okay, this is very easy, and in order to find it out I have to use the binomial probability law, which is n k p of k and 1 minus p n minus k. okay, let me put these values. So the value of n is 8, the value of k is 3. okay, it will be here. The value of p is 0.6, 0.63, and 1 minus p, 1 minus 0.6 is 0.4. okay, so it will be n minus k, so 8 minus 3 is 5. okay, so by using it you have to use what? It will be 8 factorial divided by 3 factorial. 8 minus 3 is 5 factorial. It would be 0.6 cube and 0.45. okay, so by solving it you will get the answer of your question, which is here. So it is very easy. In part B of my question, at least 5 began taking Valium for problems that were not psychological. okay, so now we have to see that here the problem is different. Here we have seen them that exactly 3 taking Valium for psychological problems, while here these are not for the psychological problems, which means we have here the probability of the positives for this one would be 1 minus p, and that would be 1 minus 0.6, and it would be 0.4. okay, you have to keep in your mind that here the not psychological is basically the opposite of it. So therefore what we will have to do here, we have to find the probability that k prime, which is the not psychological, is having the range which is at least 5. At least 5 means k is greater or equal to 5. okay, and we can also find it out by 1 minus probability of k prime is less than 4. okay, so here we have to do what? 1 minus probability that x is, let me remove it first, so removing them first because this was a previous question. okay, so let me write it here. 1 minus k prime is less than 4. it would be what? K prime is equal to 0 plus and up to the probability that k prime is equal to 4. okay, so let me write the formula here. Here it would be 1 minus k prime is equal to 0 up to 4, and here it would be n, and n here is what? And here is the same, which is 8. okay, 8 k prime, but here the probability of it will be the changed one, and that is the positive probability, which is 0.4, 0.4, and here it would be k prime, and also here 1 minus 0.4 here would be what? It would be 0.6, which is basically originally positive, but here in this case it is negative, because negative of negative is positive. Okay, you have to keep in your mind that here not psychological problems users are basically 0.4, while the psychological problem users are basically 0.6 probability. Okay, and here I have to write here 8 minus k prime. Okay, so you have to find it out, and it will be basically the answer of 5.8 part B. Okay, so that is basically the solution of question 5.8. and what was basically the twist? I have told you here that it was a twist, and you have to be very attentive to the statements, and you have to see that what is required. Now going to question 5.9, let me remove it first. So in question 5.9, in testing a certain kind of truck tire over rugged terrain, it is found that 25% of the trucks fails to complete the test run without a blowout. Out of the next 15 trucks tested, find the probability that 3 to 6 have blowouts and B is fewer than 4 have blows out. So here again you have to first see that what is the probability of blowing out, that is 0.25, and what are basically the total number of trucks? Those are basically what? 15. Okay, in part A, what do we have to find out? We have to find the probability that the trucks blown out are basically ranges from 3 to 6, are greater or equal to 3, and less than or equal to 6. Okay, and here it would be what I have to use here. Again, k is from 3 to 6, and here it will be n k. The probability of it will be 0.25, 0.25, and here k, and 1 minus 0.25, 0.75. Okay, and here n minus k. It will be like this one. For part B of my question, fewer than few have blows out. Okay, so I have to find out the probability that k is what? K is less than 4. Okay, and this is what we can very easily see, that it will be from k equal to 0 up to k is equal to 3. Okay, you have to find them out all, and here the answer of it will be the solution of part B of it. And you can also write it like from k equal to 0 up to 3, and here n of k. Okay, probability of k, and here 1 minus p probability, and n minus k. Okay, so this is what this would be the solution of part B of question 5.9. So that's it for today's video, in which we have seen the solution of question 5.7, 5.8, 5.9. Though I did not give you the answers have been listed in your textbook as well, but you have to see that what are basically the conceptual overviews, how to see that whether a problem is relevant with the binomial probability law, and how to solve them, what are the approaches. And that's it for today's video. If you have any questions, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is chapter 5, and today we are going to discuss question 5.11, 5.12 and 5.13. Okay, so let us first talk about question 5.11. Okay, so the statement of it is the probability that a patient recovers from a delicate heart operation is 0.9. What is the probability that exactly 5 of the next patients having this operation survive? Okay, so survival is basically the positive, while not survival is basically the negative or false. Okay, so therefore we have to find out the probability that 5 patients out of 7 will have to survive. So therefore this is the probability of the survival, and it is what? This is 0.9, and the probability of no survival would be how much? That would be k q, and it is 1 minus 0.9, so it would be 0.1. Okay. Similarly, the total number of patients here are n equal to 7, and we have to find that exactly 5 of them basically survives. Okay, so k is 5 here. What do I have to find out here? I have to find the probability that k is equal to 5, and again we can see very clearly here that this is the problem of the binomial probability distribution. Okay, so for this part we have this one, and for it we clearly know that the formula for the binomial probability distribution is n choose k. Okay, probability raised to power k and q, which is 1 minus p, that is n minus k. Okay, so we have all these values here. Let me put them here one by one. So this is 7 choose 5. Okay, for this one here, and the probability here is 0.9, so 0.9 raised to the power 5. Okay, and q is 0.1, and 7 minus 5, because n minus k is 7 minus 5, so here it will be square. Okay, so let me find it out. 7 factorial divided by 5 factorial, and 7 minus 5 is 2 factorial. Similarly, finding them out, 0.95, 0.1 square. Okay, so then ultimately calculating and finding it out, what will be the answer? The answer here will be 0.1240, and that is what? That is basically the solution of question 5.11. Okay, so this is the solution of question 5.11, and we have done it. Now let us move toward question 5.12, and the statement of it is: a traffic control engineer reports that 75% of the vehicle passing through a checkpoint are from within the state. Okay, so let me write this given data here. So question 5.12. okay, and this is the given data, and in given data the probability that the vehicles are within the state are 75%. So the probability of within state is w, and this is 0.75. okay, so what is the probability that fewer than 4 of the next 9 vehicles are from out of the state? Okay, so from this probability we can very clearly see that if the probability that within the state vehicles are 0.75, the probability that out of state, okay, out of state is what? Or let me write it with O. Out of state it would be 1 minus 0.75, or it would be 0.25. Okay, so now what do we have to find out? What is the probability that fewer than 4 of the next 9 vehicles? Here n is 9, and here we have to find the probability that k is less than 4, and we have to find the probability that k is less than 4, and here we can see that these are out of the state, means this is the probability which we were seeing. Okay, so this is the probability for the true, and this is for false, means this is q here and this is here p. Okay, so let me solve it here. Let me move down somehow. Okay, so I hope this statement is now clear to you guys. So finding the probability that k is less than 4, so it is what? It is the probability that k is less than or equal to 3, which is what? Which we can find out very clearly by all the values of k which are less than or equal to 3. So k equal to 0 plus k equal to 1 plus k equal to 2, okay, and plus k equal to 3. Okay, we can also write it like here. Let me use another color for it. Let me use this blue color. So we can also write it like the probability of k equal to 0 up to 3, okay, and writing the formula, because each one here corresponds with the binomial probability law. So here n choose k p of k, okay, and q would be n minus k, okay. Similarly, using the binomial probability formula for each one of them here, what would I get here? Applying this formula for all of them, what would I get here? The answer of it would be 0.8343, okay. So that is what, that is basically the solution of question 5.12. okay, so you have seen that what is the difference between this and the other question is that here p and q are different from whatever is given, so you have to keep your eyes on the required things, that what is required. So out of the state required, while within the state probability has been given. Similarly, for question 5.13, a nationwide survey that examined attitudes about antidepressants revealed that approximately 70% of respondents believe antidepressants do not really cure anything. They just cover up the real trouble, okay. So that is basically a belief which 70% of the patients basically believe in. According to this study, what is the probability that at least 3 of the next 5 people selected at random will hold this opinion, okay. So from the overall population, the probability of holding this opinion is 70%, okay. So let me solve it here. This is question 5.13. so the probability of holding this opinion is 70%, which is 0.7, and the probability of not holding this opinion would be 1 minus p, or 1 minus 0.7, and that would be 0.3. okay, so I hope you have got it. So now the next selected people are basically 5, so n is 5, and we have to see that at least 3 of the next people basically hold this opinion. So we have to find out that the probability that k is greater or equal to 3, and it would be what? It would be k equal to 3 plus k equal to 4, okay, and plus k equal to 5, okay. So these are basically all the values, and this is again the case of the binomial probability law. So let me again use the formula for k equal to 3 up to 5, and n choose k, okay, and probability k while q n minus k, okay. Putting values here, what I will get, k equal to 3 up to 5, n is how much? N is 5, okay, this is k, and p is how much? That is 0.7, 0.7 k, and q is 0.3, and it would be 5 minus k, okay. Now solving it and then finding all the values here, we will very clearly see that solving them individually for all the values of k and then adding them together, it is very easy to see that the answer of it is 0.8369, okay, and that is what, that is basically the solution of question 5.13, okay. So that's it for today, in which we have seen some use cases of the binomial probability law and how can we apply the probability distribution function, which is in the form of the binomial probability. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 5.14. and the statement of it is the percentage of wins for the Chicago Bulls basketball going into the playoffs for the 1996-97 season was 87.7. okay, so this is the probability of winning. Round the 87.7 to 90 in order to use table A.1, which is given in your book, and as we are not going to use the table A.1, but let us assume that we have been rounding it from 87.7 to 90, so that's why probability here would be 0.9. so therefore the probability of losing would be q, which is what, which is 1 minus p, and p is 0.9, so 1 minus 0.9 is 0.9. 1. Okay. So on the basis of this data, what do we have to do? We have to find the answers of some parts of it. So part A of this question is, what is the probability that the Bulls sweep 4-0 the initial best of 7 playoff series? Okay. So initially this sweep means the Bulls has to do what? It will play 4 games, and out of those 4 games it has to win all of those 4 games. Okay. So therefore again this is the problem of the binomial probability law, and I have to find the probability that k equal to 4, and this is 1. The formula of it is n choose k p k q n minus k. Okay, let me put all these values here. So n is 4, k is 4, okay, according to this here, and p is 0.9, 0.9 raised to power 4, and 0.1. 4 minus 4 is 0. Okay, so here what would we get? Here it would be 4 factorial divided by 4 factorial into 0 factorial, because 4 minus 4 is 0. Here it would be 0.9 raised to power 4, 0.1, it would be 1. Okay, multiplying all those terms, these will be cancelled out, and finding the 0.9 raised to power 4, what would I get? Here answer of it would be 0.6561. Okay, and that is what, that is the solution of part A of my question. Okay, now in part B, what is the probability that the Bulls win the initial best of 7 playoff series? So winning the playoff series means that it is playing best of 7, and in best of 7 it will win the series if the winning is greater or equal to 4, means all the values of 4, 5, 6, 7, it means winning the series. So therefore what do we have to find out? We have to find the probability that k is greater or equal to 4, which is what? Which is probability that k is equal to 4 plus probability that k is equal to 5 plus probability that k is equal to 6 and plus probability that k is equal to 7. Or we can also write it like from k equal to 4 up to 7, we have to find all the probabilities that k is equal to small k. This is, let me have here, this is small k, or as this is what, this is the problem of the binomial probability. So that's why writing it like this one, k is equal to 4 up to 7, here writing the formula for the binomial probability law, which is n choose k. Okay, p is k and q is n minus k. Let me write all these values here. Here it would be k equal to 4 up to 7. Okay, the value of n is now what? This is now 7, because the games here are basically 7 games, which has been written here as well. And all the values of k would be from 4 to 7, because this is the winning, and we have been leaving it here because putting them all together and then adding them all will give us the answers. And here the probability of it is, or the probability of winning is 0.9, which is the same as mentioned here. So 0.9 raised to power k, and q is what? Q is 1 minus p. So 1 minus p is how much? That is 0.1. So 0.1, and here 7 minus k, which is n minus k. Okay, given here as well. Now after finding all these values and adding them together, which you can do very easily, the answer of it would be what? The answer of it will be 0.9973. Okay, so that is what, that is the answer of part B of my question. Part C is, what very important assumption is made in an answering parts A and B, and that is the only assumption which is already given in the statement is, and that is the rounding of the winning from 87.7 to 90%, and that is the probability that is 0.9. Okay, so this assumption has been made, which is common in all of them. You can see that it is already given here that the probability of winning is 0.9. Here it is also 0.9. So this is the only assumption which has been made. So that's it for today, in which we have seen the solution of question 5.14. So see you soon. Welcome back, guys. I hope all of you will be fine. So this is question 5.15 of chapter 5. And the statement of this question is, it is known that 60% of the mice inoculated with a serum are protected from a certain disease. Okay, so the probability that a mice has been protected is 60%. Let me write this given data here as well. Let me write it here. So the given data, the probability that the mice are basically protected from the disease are what? This is 0.6. Okay, because this is 60%. So if 5 mice are inoculated, find the probability that. Similarly here, the number of mice here are 5. Okay, similarly from it we can also do what? We can see here that if the probability that 0.6% of the mice are protected, so the probability of the disease contraction is basically contracts. This would be what? This would be 1 minus 0.6, which is 0.4. Okay, so now this is what we wanted to have. So on the basis of this statement, on the basis of this data, what do we have to do? We have to find that the out of those 5 mice, none contracts the disease, fewer than 2 contracts the disease. Okay, and C, more than 3 contracts the disease. Okay, so let me first solve part A of my question. So in solving it, this is part A, and in part A we have to find that none contracts the disease, and here we can very clearly see that this is a Bernoulli trial in which we have either the protected or contraction or non-protected. Okay, so this contracts is basically the true and this is false, and similarly on the basis of it we call this is basically P, which is 0.4, and this basically Q, which is 0.6. Why? Because here we can see that we have to find the probability of the contraction. In each statement here we have to see that what is the probability that the certain number of the mice are contracted. So therefore I have been taking this probability as the positive one, while this one is for the negative one. Okay, so I think it is clear now. So now in order to do so, we can very clearly see that these are basically the number of Bernoulli trials. So in order to find the probability of certain Bernoulli trials, we have to use the binomial probability law. So here, in order to find that none contracts the disease, we have to see that K is equal to 0, which is mean by none. Okay, so here we have to use and choose K, P of K and Q of n minus K. Okay, we have all these values. So let me write the value of n, which is 5, choose 0, which is given here, and P is what? This is 0.4. Okay, with respect to 0, and Q is what? This is 0.6, and it would be 5 because 5 minus 0 is 5. Okay, let me find them out. So it will be 5 factorial divided by 5 factorial into 0 factorial. It would be what? Something raised to power 0 is 1, and 0.6 raised to the power 5 is how much? This is 0.0778. Okay, so these will cancel out. This is equal to 1, and ultimately the answer of it would be 0.0778, and this is what? This is the solution of part A of my question. Okay, so this is what I have found out. Now let us move to part B of my question. Fewer than 2 contracts a disease means we have to find out the probability that K is less than 2, which is what? which is the probability that k is equal to 0 plus probability that k is equal to 1. Okay, as we have already found out the probability that k is equal to 0, we can also write it here in this question, and this would be 0.0778. okay, let me find it out, and it would be what? It would again be the binomial probability theorem, and writing and choose k, we will have here 5 1, probability is 0.4, writing this power k, which is 1, and 0.6, and it would be 5 minus 1, this is 4. Okay, finding it out and calculating all the values, the answer of it would be what? The answer of it would be 0.3370. okay, that is what? That is basically the solution of part B of my question. Okay, let me move down somehow to solve part C of my question. Okay, so let us move to part C, and the part C of my question is more than 3 contracts the disease, means probability that k is greater than 3, or it can also be 1 minus probability that k is less than or equal to 3. okay, whatever is feasible for you, you can do it, but in this scenario we can very clearly see that probability that k is greater than 3 will be easier for me if I find out for the probability that k is equal to 4 plus the probability that k is equal to 5. okay, so this is what we have. Let me move down somehow. Okay, here, so writing the values here, and this is again the binomial probability law, so it would be and choose k, p of k, q of n minus k, plus again here and choose k, p of k, q of n minus k. okay, writing these values here, the value of n will remain the same, which is 5, while k is 4. okay, here, and the value of p is how much? This will again remain the same, this is 0.4 with 4, and q is how much? That is 0.6, and n minus k is 1. okay, similarly here we have 5, choose 5 because here again we have 5. okay, p is how much? It will remain the same, this is 0.45, and q is 0.6. okay, raised to power 0. okay, solving them all, so ultimately the answer of it would be 0.0870. okay, and that is what? That is the solution of the question we have found out. okay, so in doing so and writing the answer directly, I assume that you can do all these calculations manually as well, because here this is what? This would be 5 factorial divided by the 5 factorial, and it would be 5 minus 5, it will become 0 factorial, and here it will become what? It would be 5 factorial divided by 4 factorial, and then 5 minus 4, which is what? This is 1 factorial, and this is why? Because here I have been using the formula that n factorial divided by k factorial and minus k factorial, and this is for what? Let me remove it. This is for what? This is for n, choose k, and I have been using it all in this question. okay, so that's it for today, in which we have seen the solution of question 5.15. if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 5.16 of chapter 5, and today the statement of the question is: suppose that airplane engines operate independently and fail with the probability equal to 0.4. okay, assuming that a plane makes a safe flight if at least one half of its engines run, determine whether a 4-engine plane or a 2-engine plane has the higher probability for a successful flight. Okay, so here we have, you can see that the two scenarios in which either we will have 4-engine plane or 2-engine plane. Okay, and we will also try to divide this question into two parts, but before it, first of all, let us see that what is the probability of the engine failure or success. So the failure probability here is 0.4. So the probability of failure is basically here, and this is P of F. P of F is what? This is 0.4. So on the basis of it, we can also find the probability of success as well, and that would be what? That would be 1 minus the probability of failure, and it would be 1 minus 0.4, which is what? 0.6. Okay, so this is what? 0.6. Let me take it and move it from here to the other side. Okay, let me place it here. Okay, so now here, in order to solve it, what do we have to do? We have to keep it in two cases. Okay, we will have case 1 and we will have here case 2, and in those two cases we have to see that what is the probability of success in these two cases. Okay, so in case 1 we have the number of engines equal to 4, and in case 2 we have the number of engines equal to 2. Here we can see that these are the two cases, 4 engine and 2 engines, and in each of these cases we have to see that what is the probability that the number of engines operate successfully are half or greater than it. So therefore here the value of k is half of it, that is 2, and here the number of engines half here are basically 1. Okay, what do we have to find here? Here we have to find here the probability that the k is greater or equal to 2, and here we have to find that the probability that k is greater or equal to 1. Okay, so I hope it is now clear. Now let us proceed to case 1, and here in order to find it out, we can very clearly see that this is also equal to 1 minus the probability that k is less than 2. Okay, also let me do it like this one, that 1 minus probability of k is less than 2 would be what? It would be the probability that k is equal to 0 plus the probability that k is equal to 1. Okay, and this is basically the case of the binomial probability, because again we have two cases, failure and success, and this success is basically the true case, which is P, while this failure is what? This is false, which lies in the Q, because here we have to find the successful flight. Okay, so for the successful flight we have, this is the success rate, and we have to use it here. Okay, so let me use it here, the binomial probability law, and here what would happen, and choose k multiplied by the probability of success and q then. So here the number of n's here are basically 4, so n, choose k, and then p, and then q, p, k, qn minus k. Okay, and also here for k equal to 1 we will do the same, and k probability k q of n minus k. Okay, this is here. Let me move down somehow. Okay, and here in order to do so, let me put values here. The n here for the first case is 4, choose 0. Okay, the probability of success is 0.6. Okay, 0.60, and this is q, this is 0.4, and minus k is 4. Okay, similarly here 4, choose 1, the probability of k, this is 0.6 raised to power 1 and 0.4 cube. Okay, so let me solve it again. 1 minus 4, choose 0 will be 1, 0.6, this will also be 1, because anything raised to power 0 is 1. So here we will have 0.4 raised to power 4 plus 4, choose 1, this is 4 multiplied by 0.6 plus 0.4 cube. Okay, so in solving it, what will I get? It would be 1 minus 0.1792. okay, which will ultimately give me 0.8208. So this is the solution for the case 1 where the number of engines are 2 and the success of getting operational engines greater or equal to 2. Okay, this is for the case 1. Let me proceed to case 2 and let me separate them out. Okay, this one. So this is case 2, and here in order to find out this one, I can very clearly see that this is 1 minus probability that k is less than 1. So it would be 1 minus probability k is less than 1 is k equal to 0. Okay, using the binomial probability law again. So here 1 minus now n is 2, choose 0. Okay, and the probability of success will remain the same, which is 0.6, and k and also 0.4 and minus k, which is square. Okay, so 1 minus 2 choose 0 is what? This is 1 minus this would also be 1, and here 0.4 square. Okay, so it will be 1 minus 0.16, or the answer of it would be 0.84. Okay, so the solution of it is 0.84. So we can very clearly see that the probability of the success here is higher for the number of engines where the number of engines are equal to 2, which is very astonishing. And we can see that by increasing the number of engines, if the success rate is the same, which is 0.6, we can see that the higher successful flight will be made if the number of engines will be equal to 2, as we can see here, because here the success rate is 0.6. okay, and the other condition is that if half or more than half of the engines are in operational mode. Okay, so that's it for today, in which we have seen the performance of the binomial probability law in decision making for the airplane engines operation. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So today we are going to talk about question 5.17 and 5.18 of chapter 5. These two questions are closely relevant with each other, and today we are going to talk about the mean and variance of the binomial probability distribution. So mean of the binomial probability distribution can be written as NP, where n is basically the number of items and p is the probability of the positive or probability of the happening of something. Similarly, variance of the binomial probability distribution can be written as np 1 minus p. Okay, as 1 minus p is q, so therefore it would be np q. Okay, it is represented as sigma square, and this is what? This is mu. Okay, so this is what we have to utilize today. And in question 5.17, we have to see that if x represents the number of people in exercise 5.13 who believe that antidepressant do not cure but only cover up the real problem, find the mean and variance of x when 5 people are selected at random. Okay, so here in question 5.17, okay, let me write here the given data with it. Here the number of items or number of people are basically 5, and what do we have to find out? We have to find out the mean and b variance of it. Okay, as we know here that mean is equal to np, where variance is npq. Okay, we don't know the value of p, and that is already given in question 5.13. Let us go to question 5.13 now. So this is question 5.13, and here we can see that what was basically the value of p. Here we can see that a national study that examined attitudes about antidepressants revealed that approximately 70% of respondents believe antidepressants do not really cure anything, they just cover up the real trouble. Okay, so here it can be very clearly see that p is 0.7. okay, so q, which is 1 minus p, that is 0.3. okay, so let us get back to our question. So here, as we have been given that P is 0.7 and Q is 0.3. Okay, so let me put these values here. This N is 5 and P is 0.7. So it would be 3.5. Okay, also here putting the values here, N is 5, P is 0.7. Okay, and Q is 0.3. Okay, so it will be something like 1 point something, or this would be sigma square. Okay, similarly, if you want to find out the standard deviation, which is sigma, so you have to do what? You have to take the square root of this sigma. Okay, so this is what, this is the standard deviation, and we have found out the values by them, and these are basically the answers of our questions. This is 3.5, and this is here, you have to calculate it, and then you will get the answer here. Now let us move towards question 5.18, and in question 5.18, Part A is in exercise 5.9. How many of the 15 trucks would you expect to have blowouts? And B, what is the variance of the number of blowouts experienced by the 15 trucks? Okay, so here it is very clear that in question 5.18, the number of items here are basically how much? These are 15. Okay, so these are 15, and in order to find the mean of it, this is part A. And in order to find the mean of it, we know that mean is what? This is NP, and B is for variance. Okay, this is for variance, and the formula for variance will remain the same, and that is NPQ. Okay, in question 5.9, let us see the value of P, which is here not known. So let us move to question 5.9. So this is question 5.9, and here we can see that in testing a certain kind of truck tire over rushed terrain, it is found that 25%. Okay, so P is here what? This is 0.25, and Q is how much? That would be 1 minus P. So 1 minus P is 0.75. Okay, so these values are known here. So let us move back to our question. So P was 0.25, and let me put these values here. So it would be 15 multiplied by, let me change the color here. So it would be what? NP. So NP is, N is 15 multiplied by 0.25, and here the answer of it will be here. Similarly, for the variance of it, which is sigma square, what I will get here, N is 15, P is 0.25, while Q is how much? We have also found out Q, and that was 0.75, and multiplying with it 0.75 as well. Okay, so this is what, this is basically the solution of question 5.17 and 5.18, which are basically related with the mean and variance of the binomial probability distribution. Okay, so that's it for today, in which we have discussed the meaning and solution of the questions which are related to mean and variance of the binomial distribution. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 5.19 of chapter 5, and today we have been starting another very important topic that is related to the multinomial probability. Okay, let us first go through the statement of this question. As a student drives to school, he encounters a traffic signal. This traffic signal stays green for 35 seconds, yellow for 5 seconds, and red for 60 seconds. Assume that the student goes to school each weekday between 8 and 8:30 a.m. Let x1 be the number of times he encounters a green light. Okay, x2 be the number of times he encounters a yellow light, and x3 be the number of times he encounters a red light. Okay, find the joint distribution of x1, x2, and x3. Okay, so this is the statement, and in order to solve it, here we can also see that the case here is that we have one light which is green, the other one is yellow, and the third one is red, and each one lights up for a certain amount of time, and let x be the number of times he encounters a green light, x2 be the number of times he encounters a yellow light, and x3 be the number of times he encounters red light. So we have to find the joint distribution for x1 and x2 and x3. So this would be what? This would be the case of the multinomial probability. Okay, so in order to find the P1, what do we have to do? In order to find P2, in order to find P3, what do we have to do? P1 is the probability of the which light. This will be the first one, which is 35. So 35 is here. P2 is 5, and for P3 I have to write here 60. Okay, but these are the seconds. In order to find the probability out of them, we have to add all the numbers together, which are 35 plus 5 plus 60. Okay, similarly here 35 plus 5 plus 60, and for this 60, 35 plus 5 plus 60 as well. Okay, so from it I will get the probabilities. Let me move down somehow, and here in order to find the P1, what it would be? It would be 35 divided by the number of seconds for the first light plus the number of seconds for the second one and the number of time for the third one, because this is the total time. Okay, this is what? This is for the number of time for the first one, while this one is for the total, which is n1 plus n2 plus n3. Similarly, for P2, I have to write what here? It will be 5 divided by 35 plus 5 plus 60, which would be n2 divided by n1 plus n2 plus n3. Okay, and for P3, I have to write what? 60 seconds divided by 35 plus 5 plus 60. So it would be the n3 divided by n1 plus n2 plus n3. Okay, and finding them out, it will be 0.35, it will be 0.05, and it would be what? It would be 0.6. Okay, adding them all together, we will see that when we will add them together, so P1 plus P2 plus P3, this will be equal to 1. Okay, now taking these values and putting them all in this formula, because this is the multinomial probability and we don't know the number of times that green lights up, the yellow lights up, and red lights up. So taking them generally, and for taking them generally, let me take the number of time the green one lights up is equal to x1, and this is the small x1. For x2, this is small x2, and for x of 3, this is small x3. Okay, so putting them up, we have to find the probability of x1, x2, x3. It will be what? It will be the n factorial divided by the x1 factorial, x2 factorial, x3 factorial, and their probabilities, which will be p1 x1, p2 raised to power x2, and p3 raised to power x3. Okay, so let me write their values. Here we have to note down that this is the multiplication all over, and n is equal to x1 plus x2 plus x3. Okay, let me write their values. So n is unknown, x1 factorial, x2 factorial, x3 factorial, and the probabilities are already known. So it would be 0.35 raised to power x1 multiplied by 0.05 raised to power x2, and the last one is 0.6 raised to power x3. So this would be what? This would be probability of x1, x2, x3, and this is what? This is the solution of our question, which is what? Which is related to the multinomial probability. Okay, so that's it for today, in which we have started our problem from a very core concept of the binomial probability law, and we have extended it to the multinomial probability, that how to identify that whether a certain problem is related to the multinomial probability or binomial probability. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 5.20 and the statement of this question is, according to USA Today, March 18, 1997, of 4 million workers in the general workforce, 5.8% tested positive for drugs. Of these testing positive, 22.5% were cocaine users and 54.4% are marijuana users. Okay, so on the basis of this data we have to find that what is the probability that of 10 workers testing positive, 2 are cocaine users, 5 are marijuana users and 3 are users of other drugs. Okay, so here we can see that we have more than 2 categories, which are the categories of the cocaine user. Okay, let me represent it with C. Marijuana users, let me represent it with M, and other with O. Okay, here we will have the total number of persons 10 which are tested positive, and the people we want to see are the cocaine users are 2. For marijuana we have to see 5, while the remaining one are 3 here. Okay, out of these, what are basically the probabilities for them? For it, let me represent it with P of C, and this is what is given here, 22.5%, which is 0.225. Okay, the probability of marijuana users are basically what? The probability for that is 0.544. Okay, and the remaining one is here, which is for O. So for O are basically the other ones. So here it will be 1 minus P of C plus P of M. Okay, what it would be? Let me calculate it. P of O, it would be 1 minus P of C is 0.225 plus 0.544. Okay, so it would be what? It would be 0.231. Okay, so this is here we have. Okay, so now on the basis of it we want to find out the probability, and here again we have to use the multinomial probability law. So let me calculate it, the probability that we will have 2 cocaine users, 5 marijuana and 3 other users. So it would be what? It would be the n factorial divided by c factorial, m factorial, o factorial, multiplied by what? Multiplied by p of c raised to the power c, p of m raised to the power m, and p of o raised to the power o. Let me write their values. So here it would be 10 factorial divided by 2 factorial multiplied by 5 factorial multiplied by 3 factorial, and multiplying with them the values it has. So the probability of C is 0.225 and C is 2, so square. Similarly, P of M is 0.544 and it is 5 here, and 0.231, and the power it has is cube. Okay, so now here we have these values. Now calculating it and finding out the answer of it, we found that the answer of it is 0.0749, and that is what? That is basically the solution of part A of our question. Okay, here it is given. Now on the basis of the similar data, let us calculate or find the answer of the part B of this question. What is the probability that of 10 worker testing positive, all are marijuana users? So means we have the marijuana users, total number of positives are 10 and K, which are 10 are basically here, and these are the marijuana users. So marijuana users are here, and the probability of the marijuana users is here. So let me have this one as P. So this is 0.544, and we can see that this is the problem of the binomial probability, because here we have only one category, either a person will be of marijuana user or not. Okay, so this is the binomial probability, only one category has been given, so either a person will be of that category or not. Okay, so let me find it out. So it would be the probability that K is equal to 10. Okay, finding the values here and using the same formulation as we did previously. So it would be 10 factorial divided by this category 10 factorial and other category 0. Okay, the probability of this category is 0.544 and raised power 10, and the other one would be what? It would be q. Okay, so q would be 1 minus 0.544. So the answer of it would be what? 1 minus 0.544 would be 456, 0.456. Okay, so let me write it 0.456 raised to power 0. Okay, so calculating it, these two will cancel out. This would be equal to 1, so it would be 0.544 raised to the power 10. So the answer of it would be 0.0023. Okay, and that is what? That is the solution of part B of my question. Okay, so for solving part C, let me move down somehow. So the statement of part C is, what is the probability that of 10 workers testing positive, none is a cocaine user? Okay, so here if we have the total number tested are 10, so none are basically what? The cocaine user. So others would be 10. Okay, so here the probability of the cocaine users is what? That is here 0.225, and not cocaine users would be q. So it would be 1 minus 0.225, which would be what? Which would be 775. Okay, 0.775. So now in order to find it out, again, this is again the binomial probability. So we have to find the probability that k is equal to 0, again using the same formulation, that 10 factorial divided by 0 factorial and other categories are 10 factorial. Okay, which is same as 10 choose 0. Okay, as here we had this one and it was 10 choose 10. Okay, so we have covered all these topics in our binomial probability distributions. So here the probability of it is 0.225 raised to the power 0 because of here, and the other one, which is q, is 0.775 raised to the power 10. Okay, so this is what we have. In order to calculate it, these two will cancel out, it would be 1. So only we have to find this one, which is 0.775 raised to the power 10, and the answer of it would be 0.0782. Okay, so that is what? That is basically the solution of part C of my question. Okay, so that's it for today, in which we have seen 3 parts. The first part was there, this was part B, and this was part C. Okay, in all of these parts we have seen the usability of the multinomial probability distributions and how to use it, how to find different probabilities. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome guys. So this is question 5.22 of chapter 5, and the statement of this question is, according to a genetics theory, a certain cross of guinea pigs will result in red, black and white offspring. Okay, so let me underline them: red, black and white offspring in the ratio of 8:4:4. Find the probability that among 8 offspring, 5 will be red. Okay, 5 will be red, 2 will be black and 1 will be white. Okay, so this is clearly the problem of the multinomial probability. So in multinomial probability, let me write the formula for finding out the probability for the red equal to 5, black equal to 2 and white equal to 1. This is what? This is basically the total items, which are 8. Okay, so total items factorial divided by the number of red items factorial multiplied by the black items factorial and white items factorial multiplied by the probability
of the red items which are here and raised to the power 5 which are here. Similarly, the probability of the black items raised to the power 2 because these are the items here, okay, and similarly multiplied by the probability of the white items raised to the power 1 which is here, okay. So now here it is clear that in order to find out this probability we have to find out the individual probabilities of red, blue and white. So therefore let me write here, let me use this blue color here. So the probability of red is what? This is the number of red divided by the total number of the items, okay. So here from this ratio we can very clearly see that the total number of items or the total number of things here are 8 plus 4 plus 4 and this is 16, okay. So n of t is 16 while the ratio of the red items or red guinea pigs is 8, okay. So this is the first item, so therefore it would be 8, so this is clearly 0.5. Similarly for the black guinea pigs we have to write the black guinea pigs divided by the number of the total number of the guinea pigs. So from here we can see that these are 4, so 4 by 16, this is 0.25 and also the probability of the white guinea pigs, this would be the NW, number of the white guinea pigs divided by the total number of guinea pigs. So again from the same formulation we can see that this is 4 over 16 which is 0.25 as well, okay. So let me write here all the values. So it would be 8 factorial divided by 5 factorial multiplied by 1 factorial is 1, 2 factorial is 2, so multiplied by 2, and here writing the values of p of r which is 0.5, so 0.5 raised to the power 5, 0.25 raised to the power 2 and 0.25 raised to the power 1, okay. So from here what would I get? It would be 8 multiplied by 7 multiplied by 6 multiplied by 5 factorial divided by the 5 factorial multiplied by 2. These two will cancel out. Similarly it would be 2, 3, 6, okay, and here we would get 0.5 raised to the power 5 and also these are the similar items, so 0.25 raised to the power 3, okay. From it when I will solve it, ultimately I will get what? It would be 0.084 and that is what? That is basically the solution of our question which is related to the multinomial probability, and this is the solution of this thing which you wanted to find out, and it is here. So that's it for today, in which we have seen the solution of question 22 of chapter 5 of our book. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 5.23 and 5.24. Many times people are confused between multinomial probability and binomial probability. So in this video, I will try to demystify this concept by solving question 5.23 and 5.24, which are relevant, but one question is related to the multinomial probability theorem, while the second one here is the binomial probability law, okay. So I will try to relate them and demystify the concept of the both probability distribution. So let us first start it from question 5.23. So the statement of this question is the probabilities are 0.4, 0.2, 0.3 and 0.4 respectively that delegate to a certain convention arrived by air, bus, automobile or train, okay. So let me also write it here. So let me represent the air with A,
bus with B, automobile with AU, and train with T. So these are what we have, and their probabilities are also given here. So let me write their probabilities. Okay, so these are all the probabilities. What is the probability that among 9 delegates randomly selected at this convention? Okay, so the total number of delegates, let me represent it with N, and that is 9. 3 arrived by air, 3 arrived by bus, 1 arrived by automobile, and 2 arrived by train. And here we can see that we have 4 classes, class A, B, AU, and T. And in order to find out the probability that the items from the first class are 3, okay, this is here. Items for the second class, which is bus, are 3 again. Items for the third class, which is automobile, it is 1. So AU is 1. And the last item, that is train, this is 2. We can see that here we have 4 classes, and in order to find the probability of this combination, what do we have to do? Here you have to keep in your mind that we will have to use the multinomial probability, because we have here multi items. So in order to do it, I will have to use the formula n factorial divided by the number of a's, a factorial, b factorial, au factorial, and t factorial, and then multiplying with the probabilities these has. This is the probability of A multiplied by the probability of B, multiplying it with the probability of AU, okay, and also with the probability of what? Probability of T. So these are what we have. Also, after multiplying the probabilities, I have to write their powers as well. So the power of it will be A, the power of P of B would be B, power of P of AU would be AU, and the probability of this last term will be T. So let me put all these values here. N is 9 here. So 9 factorial divided by A is 3. 3 factorial multiplied by 3 factorial, B is 3. This is 1 factorial, and the last item here is 2. So 2 factorial. And now with them, let me multiply the probabilities. For the first item, I have 0.4 raised to power 3. Okay. P of B is 0.2 raised to power what? This is also 3. P of AU is 0.3 raised to power 1. And the last item, P of T, is, that is 0.1 raised to power 2. Okay, so we can see here that, let me represent each item with different color. This is A, we have to write it here, and this is also written, the relevant term is here as well. Okay, for the second item, let me represent it with yellow. This is B, B is here. Okay, and the relevant probability it has is here. Okay, the third item here is, let me use this color for it. The third item is here, it is here. Okay, and the relevant probability it has is here. And the last term here, let me represent it with this brown color. So this is here, it has this T factorial, and the relevant probability it has is here. So it is very easy to see and find out all these probabilities and all these items, and we will get the answer out of them. And keep in your mind that this is the n factorial, which are basically the total number of items. So this is for the multinomial probability. In order to see that what's the difference between the multinomial and binomial probability, let us go through the question, which is 5.24, and the statement of this question is, a safety engineer claims that only 40% of all workers wear safety helmets when they eat lunch at their workplace. Assuming that this claim is right, find the probability that 4 out of 6 workers randomly chosen will be wearing their helmets while having lunch at the workplace. So in order to write it, let me first write here the given data. So probability that an engineer wears a helmet while at lunch, this is what? This is 0.4, and let me represent it with P of H. And from it we can see that the probability that he doesn't wear a helmet while lunch, this is what? This is 1 minus 0.4, so this is 0.6. So let me call it probability of H prime. Okay, so now we can see that we have two classes. Wherever I will have two classes, there I have to use what? I have to use the binomial probability, because of the bi term, which means 2. Here we have multi classes, so wherever I will have multi classes, so in order to find out the probability of the all independent events, I have to use the multinomial probability because of the term multi, which means many. Okay, so in order to find it out, we have to do what? I have to find out the probability that we have total items here are n equal to 6, and out of these 6, 4 items are here. Okay, so I have to find it out, which if I see is basically k equal to 4, and this is what? This is basically the n factorial divided by, with it I have to write k factorial and also n minus k whole factorial, and then the probabilities associated with them. So the probability that k person wear the helmet while having lunch, this is basically probability of h raised to the power k, and also the probability of h prime, okay, which doesn't wear the hat, this is n minus k. Let me put these values. So now n is 6 factorial divided by k factorial is 4 factorial, and minus k is 2 factorial, and the probabilities they have are 0.4 raised to the power 4 and 0.6, which is for h complement, this is square. So finding them out, I will see that I will get the probabilities of the item. Here you can see that this is the first item of the person we have the helmets, and this is the second probability. Let me use this blue color. This is the second item and it has the probability here. So generally I can also write it here as well. Let me choose the color, this one as well. So it would be the n factorial divided by class 1 factorial multiplied by class 2 factorial, and the probability of class 1 raised to the power class 1 multiplied by the probability of class 2 raised to the power class 2, which is similar to this one, just here in case we have two classes which are here and here. Okay, so this is basically the difference between these multinomial and binomial theorem. You can find out the answer of them by using the calculator. So that's it for today. If you have any question regarding the issues which you have in the topics of multinomial and binomial probability theorem, you can ask me in the comment box. See you soon. Hello guys, this is question 5.25 of chapter 5. And the statement of this question is, suppose that for a very large shipment of integrated circuit chips, the probability of failure for any one chip is 0.10. Okay, so let me write the given data here. So given data, let me write it with this blue color. The probability of failure is what? This is given, and this is 0.10. 1 0, assuming that the assumptions underlying the binomial distributions are met. It is already given that we are going to use the binomial distribution. Find the probability that at most 3 chips fail in a random sample of 20. Okay, so the random samples or the total number of items here are 20, and we want to find out the probability that the number of failure are at most 3 chips, means failures are less than or equal to 3. We have to find it out. Okay, so let me solve them here, and in order to solve them here we have to use what? Let me use the formula for it, and the solution of it is here. I want to find out the probability of failure which is less than or equal to 3. Okay, so in order to find it out, this is what? This is all the items which basically lies in this range are the probability that we have 0 failures plus the probability that we have only 1 failure plus the probability that we have 2 failures and plus the probability that we have the number of failures equal to 3, because at most we must have 3 failures. So the formula for it we are going to use is, let me have here the probability that the number of failures are k. This is what? This would be n choose k, and the probability of success is k and failure is n minus k. Okay, so here this p is p of f, this small n is this capital N, and this k, this is here all the items here. So for each of the item here we have to apply this formula. Okay, for each one of them, for this and for this as well. So therefore, in order to find out the probability that f is less than or equal to 3, we have to apply the similar formula for k is equal to 0, sorry, up to 3, and here we will have to apply and choose k. Okay, p of f will remain the same, raised to the power k, and here we will have 1 minus p and minus k. So 1 minus p of f, okay, and minus k. So applying it here, what would I get? I will have here and choose 0. Okay, and here it would become 1 because this is 0 and 1, and here we will have 1 minus 0.10, so we will have here 0.9 raised to the power n minus 0, so n minus 0 would be n. Okay, plus for the second item we will have and choose 1, p of f is 0.1, so 0.1 raised to power 1 and 0.9 raised to the power what? This would be n minus 1. Okay, plus and choose 2, 0.1 raised to power 2 and 0.9 n minus 2, plus here and choose 3, 0.1 raised to power 3 and 0.9 n minus 3. Okay, for all of them we have n equal to capital N, which is 20. Okay, you have to put all these values here. So let me move down somehow. So here ultimately we will get what? We will have here 20 choose 0 and here 0.9. Okay, and here 20 plus 20 choose 1, 0.1 multiplied by 0.919 plus 20 choose 2, 0.1 square and 0.91 plus 20 choose 3, 0.1 cube and 0.9. 3 minus 3 would be what? This would be 0. So rate will be 1. Okay. So finding them all here, so it would become 20 factorial divided by 20 minus 0, because you can see here that A choose B is always equal to the A factorial divided by B factorial and A minus B whole factorial, applying them all here. So ultimately from all of them together you will get what? Here you will get the probability that the failures are less than or equal to 3. So you will have the amount, let me call it x, and that would be the answer of our question. So I have told you how to apply the concepts here, how to get the answer, and whatever we have here would be the answer we have. Okay, so that's basically the solution of the question 5.25. If you have any question, if you have any ambiguity regarding the question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 5.26, and the statement of this question is: assuming that 6 in 10 automobiles accidents are due mainly to a speed violation, find the probability that among 8 automobile accidents, 6 will be due mainly to a speed violation. Okay, so we have to do it how? In part A of it, we have to use the formula for binomial distribution for finding out the solution, and B, we have to solve it by using table A.1. Okay, so let us solve it here. So the solution of it is here, and in order to solve it, we can very clearly see that here we have 8 choices, and out of those 8 choices we have 6 which should be true, or which should be the accidents which we want to find out. Okay, so first we have to find out what? We have to find out the probability of accidents. Why? Because this is clearly the problem of the binomial probability distribution. Okay, so according to the binomial probability distribution, if I want to find out the probability of x equal to k, this is what? This is the n choose k. Okay, the probability of the each item or each success here, so it would be the probability or p raised to power k and 1 minus p raised to power n minus k. Okay, looking at it here, what information did we get? We can very clearly see that here we have found that 6 in 10 automobile accidents are due mainly a speed violations. So from it we can very clearly find out the probability of these automobile accidents which are due mainly to a speed violation, and that is 6 out of 10, which is 0.6. Okay, this is what we have found out. Similarly here, we can very clearly see that among 8 automobile accidents, 6 will be due mainly to a speed violation. So the total number of automobiles here are 8, and from 8 we have to find the probability that 6 are basically due mainly to a speed violation. Okay, so all the items are given here. Let me put values here. So the probability that x is equal to 6, okay, or probability that k is equal to 6, that can be written here as well. Okay, so putting all these values here, we will get 8 choose 6, probability is 0.6, 0.6 raised to power 6, okay, and 1 minus 0.6 raised to power 8 minus 6, that is 2. Let me simplify it as well. So simplifying it, it will become 8 factorial divided by 8 minus 6 factorial, which is 2 factorial and 6 factorial as well.
okay, multiplying it with this 0.6 raised to power 6 and 0.4 raised to power 2. Okay, solving it at the end, what will we get? The answer of it, finding them all here, the answer of it would be 0.2081. Okay, so that is basically the solution for part A of my question. Okay, let me write here part A as well. So this is the solution of part A. Similarly, in part B, we are asked to find the similar solution by using table A.1. Okay, so what is the table A.1? How can we find out the values here? So here we have all the values, which is for n equal to 8, and the probability here is what we can see, that this is 0.6. This is, let me have here part B. In order to find out the probability for k equal to 6, what do we have to do? We can very clearly see that we have to find out the probability of all the items less than or equal to 6, and from it I have to subtract the values which are less than or equal to 5. Okay, why this? Because if I can see here that this is the distribution, here I have the 6, here I have 5, okay, and I have here this distribution, let me have it for this 6, okay, and I want to find out what? I want to find out this area which is here. So from this I have to subtract this area, which let me highlight in red. Okay, so in order to do so I have to subtract this area. Okay, so this area is what? This is this. Okay, and this bluish area, which is the overall, this is here. Okay, so from it we will very easily find out this area, which is the required one, and this is here we have. But what table do we want to find out? Why did I use this k less than or equal to 6 and k less than or equal to 5? Why not we simplified it by using this formulation? Let us first go to the table A.1. So this is basically the table which we were here to use. So now here you can very clearly see that this is the formula which I am going to use, and here for my previous question where I have k is equal to 6, for it I have used probability that k is less than or equal to 6 minus the probability that k is less than or equal to 5. Why? Because here you can see that here we have this symbol which is less than or equal to c. So here we have c equal to 6, here we have c equal to 5. So this is the first parameter I have to use here. This is the first parameter I have to use it. Okay, similarly the other parameter here I have to use is the n. Okay, so n is what? N is basically the total number of items which are here. So the total number of items here which I have previously seen are 8. So this is the second parameter here as well. Okay, the third parameter is this probability, which I have seen that this was 6 by 10, so which was 0.6, which I have previously seen. So this was here 0.6, 0.6 here as well. Okay, so I have to find out the probabilities of these parameters and then subtract them out. But how to find them out here? The first parameter here is 0.6. Let me choose this color here. Okay, so the first parameter here is the 0.6. So this is here. So I have to look at this column. Okay, this is the table, and the second parameter is n equal to 8. Okay, this, so here these are all the values of n. This is n equal to 1, 2, 3, 4. Okay, so let me move to the n equal to 8. Okay, so this is n equal to 8, and the third parameter here is what? This is here 6 for this one and 5 for this one. So let me move here. This is 8, and the values for the third parameters are here. So the first is here, the second one is here. So let me use them here. This is for the first one, let me use this blue color. Okay, so the first one is this one. The probability of it was 0.6 and this was 0.685. Okay, so the for 5 it is 0.685, and from it I have it should be subtracted from this one where the value of C is 6. So let me move to the same position, and here I can see that let me use another color for it, and for it let me use this green color. Okay, this green color. So this is 6 and this one, so this is 0.894. So this is 0.894. Okay, so once we will subtract them, what will be the answer? The answer of it would be, let me use another color which is this black. The answer of it would be 0.209. Okay, which is what? Which is basically the solution of the question which I wanted to find out. Okay, this is 0.209, and I have explained this table to you because this is the binomial probability equation, and you have seen that how to use this table for it. This n is basically the total number of items which are here. This C is what? This is basically the 6 and 5 which are basically found for the ranges which we have here, and the last item here is the probability, which is the probability of the true events for which we have here all the required stuff. Okay, so let us move to our page. So this is what we had, and here we have found out that this was what? This was 0.209. Okay, which is what? Which is almost the same value which we have found out by this formula, but the methodology for finding out the probability by this method is quite different than this one. But you have found out that how to utilize the binomial probability table to find out the required quantities. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.27, and the statement of this question is, if the probability that a fluorescent light has a useful life of at least 800 hours is 0.9, find the probabilities that among 20 such lights, part A of it, exactly 18 will have a useful life of at least 800 hours. B, at least 15 will have a useful life of at least 800 hours. And C, at least 2 will not have a useful life of at least 800 hours. Okay, so this is basically the statement, and now we have the table as well as the formula to solve them. So in this question we will try to solve it by using the table which we have instead of falling into the heavy calculations. So in this question, let us first write the given data here. So in writing the given data, this is the given data. Okay, so what is given? We know that the probability that life of a fluorescent light is at least 800 hours. So this is greater than 800 hours. The probability of it is given, and that is 0.9. Okay, so let me call it the probability P of the true event. Similarly, here we have the total lights which are n equal to what? 20. Okay, this is what we are given. Now on the basis of it, what do we have to find out? We have to find out, or the required quantities here are, okay, in part A we have to find what? We have to find exactly 18 will have a useful life of at least 800 hours. So we want to find out the probability that k is equal to 18. Okay, so in this video we will first find it out, and the other two parts of it we will try to solve them in our next videos. So this is part A, so let me solve it first. The solution of it is here, and in order to find it we have to find the probability that k is equal to 18. Okay, and this is what we need to use the formula which is here, and k, okay, p, which is the probability 0.9, this is k, and also 1 minus p n minus k. So let me remove them and write 18 here. Okay, so 18, and also the value of n is 20 as well, so this is 20, and it would be 20 minus 18, so here it would be 20, sorry, 18 and 2, and the p value is 0.9, so let me write it here as well, the 0.9, removing it, and it will become 1 minus 0.9, so 0.9 raised to power 18 and 1 minus 0.9. so this is what we have. When you will follow it, you will find the answer which will be equal to what? 0.2852. Okay, so this is one method which we have seen here. Another method which is based on the tables here, we can find out the probability that k is equal to 18. This can be found out by using the table, and for that we will need what? We would need probability that k is less than or equal to 18, and from it I have to subtract the probability that k is less than or equal to 17. Okay, so now we know that here, in order to find this value from the table, we have to find out the probability that the value of n is 20, k is, or let me make it more specific, c is 18, and the probability is 0.9. Okay, from it I have to subtract this, where n is again 20, okay, c is 17, and probability is 0.9. I have to take both of these values and subtract them together. So let me take these values and go to the table here. So this is the table which I was using, so let me use it here, and for it, this is what the probability is, which is 0.9. okay, the value of n is what? The value of n is 20. So let me move to the 20. Okay, so this is what we have, 20, and here these are the values for the probability 0.9, because this is basically the second last column, and the two probabilities which we want to find here are for c equal to 18 and c equal to 17. Okay, for c equal to 18 we have here this one, so this is 0.608, and the second one is here 0. Which is for 17, less than or equal to 17, this is 0.32323. So let me take them and move them here. So it is 0.608 minus 0.323. So the answer of it is 0.285, which is what? Which is the similar one which we had here, and that is what? That is basically the solution by tabular form, which is a similar one as it is here. Okay, so this is the solution for part A. Welcome back, guys. This is question 5.27, and the statement of this question is, if the probability that a fluorescent light has a useful life of at least 800 hours is 0.9, find the probabilities that among 20 such lights, part A of it, exactly 18 will have a useful life of at least 800 hours. B, at least 15 will have a useful life of at least 800 hours. And C, at least 2 will not have a useful life of at least 800 hours. Okay, so this is basically the statement, and now we have the table as well as the formula to solve them. So in this question we will try to solve it by using the table which we have instead of falling into the heavy calculations. So in this question, let us first write the given data here. So in writing the given data, this is the given data. Okay, so what is given? We know that the probability that life of a fluorescent light is at least 800 hours. So this is greater than 800 hours. The probability of it is given, and that is 0.9. Okay, so let me call it the probability P of the true event. Similarly, here we have the total lights, which are n equal to what? 20. Okay, this is what we are given. Now on the basis of it, what do we have to find out? We have to find out, or the required quantities here are part A of it. We have to find what? We have to find exactly 18 will have a useful life of at least 800 hours. So we want to find out the probability that k is equal to 18. Okay. B is the probability that at least 15 will have a useful life of at least 800 hours. So at least means, okay, greater or equal to, so k should be greater or equal to 15, which is at least, and maximum is 20 because the total number of items here are 20. So this is required. And in part C, we have to find out that at least 2 will not have a useful life of at least 800 hours. So at least 2 will not have means the probability that the useful lives will be less than or equal to 18. Why? Because 2 is the lowest range of the not working lights. Therefore, 18 is the maximum range of useful lights. Okay, so therefore I have written it like this. So now in order to solve it, let me solve it here. This is the solution. Now in order to solve part B of my question, let me use this color as well. So this is B, and probability that I want to find out the probability that k is greater or equal to 15. But now this calculation will be very heavy. In order to do so, I'm going to use the table. So therefore, in using the table, I have to convert this symbol into the less than or equal to. So it would become 1 minus the probability that k is less than or equal to 14. Okay, or it would be 1 minus, I have to find out the probability where the value of n is 20. Okay, the probability is 0.9 and the value of C is 14. Okay, and I had to subtract it from 1. So let me go to the table again. So here we have a table, and let me choose another color for this question. So this is 14. This is what? This is for 0.9 probability. This is because this is the second last column, and the value of C is 14. So this is 0.011. So let me take it and put it there. 0.011, and subtracting it, what I will get? 0.989, and this is what? This is basically the solution for part B of my question. Okay, so this is the solution for part B. Now in order to solve part C, let me move down somehow. So in part C, I have to find out the probability that k is less than or equal to 18. So again, this is a very hefty calculation. The other way I can do it, I can use it like 1 minus probability that k is greater or equal to 19, or it would become 1 minus the probability that k is equal to 19 plus the probability that k is equal to 20. Okay, finding them again by using the formula, which is the binomial formula for the k value of 19 and 20, adding them together and subtracting them, I will get the answer. But if I have a table, I can directly find out the value for k is less than or equal to 18. So now here I have to find out the formula in which the value of n is 20, probability is 0.9, and the value of C is 18. Okay, so this is what we have to find out. So let us move to the table again. This is the table, and here I have to find out the value for 18, and this is here which I had. So this is 0.608. So now 0.608, and that is what? That is basically the solution of part C of my question. Okay, why did I not change it to or not subtract it from 1? Because this one is already less than or equal to 18, and I have previously told you that in this formula, in this table, I must have to use this one, and you can see that I have here less than or equal to C. So I have to convert all these values into this form. Okay, so now this one is already in that form. So that's it for today, in which we have seen the solution of question 5.27 and how to use the probability table, which can reduce the computation time and also give you the answer in the minimum time as well. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon.
Hello guys, this is question 5.28, and the statement of this question is: a manufacturer knows that on average 20% of the electric toasters produced require repairs within 1 year after they are sold. When 20 toasters are randomly selected, find appropriate numbers x and y such that, and part A of it is the probability that at least x of them will require repair is less than 0.5, and B, the probability that at least y of them will not require repair is greater than 0.8. Okay, so these are basically two parts, and first of all, in writing the solution of it, we have to write the given data here. Okay, so given data, we can very easily see that the probability of repairing a toaster is 20%, which is 0.2. So the probability here is
0.2. Okay, and the total number of toasters here are 20, so n is 20. Okay, so on the basis of it we have to find two numbers which are x and y. So in part A of it we have to find the probability that at least x of them will require repair is less than 0.5. so in solving it, let me solve it. So solution of part A, and here we have been given this probability, which is the probability that x is less than or equal to k. Okay, and also we are also given the values of n and p as well. So here we are given the value of n, which is the formula here. Let me write the formula here: p of k 1 minus p n minus k. Okay, we have been given here different values. So the values we are given here is probability of it is, this is less than 0.5. so less than 0.5 would be 0.4 something. Okay, 0.49 or something like this. And also the value of n is 20. The value of k here is what? That is x, which we want to find out. Okay, and the probability here is 0.2. the power of it is now x, and this is 1 minus 0.2, and here we have to write 20 minus x. Okay, so what do we have to do here? In this right hand side we have to take all the values of x and we have to use them one by one, from starting from 0, 1, 2 up to 20, and see that what will be the value which will at most be equal to this one. Okay, so this is the essence of these type of questions. Apart from it, if we want to avoid this step, what we can do here, we can use the binomial probability table. Okay, in binomial probability table, what would we do? We have to find out the probability of the terms where n is 20. Okay, the probability is 0.2. okay, and the value of c is x. We have to find it out, for which the value is 0.49. okay, or less than this. Okay, so this one is less than 0.5, for which I have taken it, and wherever it will meet this value we will get that value which would be equal to x. So let me go to the table here. So now this is the table. Let me use it, and let me first go to what? Let me first go to the value n equal to 20. Okay, for this question similarly the value of probability is 0.2. so I will use this first, second and third column. Okay, and there I have to see different values. So let me first move to n equal to 20. So this is n equal to 20, and this is the column of 0.2. this is n equal to 20, and here I have to see that what is the value which is basically less than 0.5. so here this is the value which is less than 0.5, and at this value I have to find out the value of c, which is given here 3. so 3 is what? 3 is the value of x, which is here. So okay, so this is the question which we were solving here. The answer of it is 3. so let me go back. So this is here, and the answer here we have found out is x equal to 3, and this is what? This is basically the solution of part A of my question. In part B of my question, the probability that at least y of them will not require repair is greater than 0.8. okay, so first of all I have to find out the value of y for the range which will not require this one, and then subtract it from the overall values which are 20 here. Okay, so I will have to find out the probability of it, okay, for the same value. So let me move to the similar table. Okay, this is the table, and here the probability is 0.2, and I have to find out the value for which it is greater than, slightly greater than 0.8, and this is here. Okay, this is 0.80, and the value here is 5. So this value is 20 minus 5, so it will give me y. 20 is what? This is n. Here this one is the value of c, so y is equal to n minus c, so the value of y here would be 15. Okay, so you can very easily see that this is 15, because there the question is at most the value of it is greater than 80%. So let me go back, and here in this question the probability that at least y of them will not require repair is greater than 0.8. so y which basically required the repair were c, so those were 5. So the items we did not require the repair were 20 minus 5 were 15. Okay, so therefore the answer of it, which is y, and that is 15. Okay, so that is what, that is basically the solution of part B of my question. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.29, and the statement of this question is: a homeowner plants 6 bulbs selected at random from a box containing 5 tulip bulbs and 4 daffodil bulbs. Okay, so basically the total number of bulbs here are 5 plus 4 equal to 9. So what is the probability that he planted 2 daffodil bulbs and 4 tulip bulbs? Okay, so from these 9 he has selected 6 bulbs. Okay, so he wanted to know that what is the probability that he planted 2 daffodil bulbs. Okay, so out of them 2 are daffodil bulbs and 4 are tulip bulbs. Okay, so now you can see here that these are basically the total number of bulbs. From it he has selected 6 bulbs, and in those 6, what is the probability that 4 are of some class and 2 are from the other class? Okay, so this is what, this is another case which is called basically the hypergeometric probability distribution. Okay, so in hypergeometric probability distribution, what we have here already and always, we have here the combinations of the total elements, and here we have seen that we have basically the total number of elements and from those and we have selected small n. Okay, so in those small n, again we can see that we have 2 classes. First class is, let me call here k, and from those k I have selected x. Okay, similarly the other n minus k are the other elements, and from it I have selected n minus x. Okay, so in all of these cases I can very clearly see that k plus n minus k, this is equal to n. Okay, the upper one, and in the lower one x plus n minus x, this is n. Okay, so this is the hypergeometric distribution, and I can very easily write it like x semicolon n comma small n, and then the last one here is this k. Okay, so this is what, this is the probability distribution which we are going to use here. Okay, so here let us first use or see the elements which we have here. So here it is clearly seen that this n is 9. Okay, also the selected bulbs are 6, so this is the small n. Okay, so these are basically the bulbs which we have. The first case are basically the 5 tulip bulbs. Okay, 5 tulip bulbs. So K is 5 and X is what? From the 5 tulip bulbs, I have to select 1. So this is 4, and also the remaining ones here would be the N minus K. So N is 9. So 9 minus 5 will be 4, and N minus X. So 6 minus 4 will be 2. So let me write all these values here. So this would become what? Let me choose another color, and this is, let me use this brown color. So here now we will have what? This X, which I have written here, is this 4. Okay, this 4 is what? This is for the 4 daffodil bulbs from the total number of bulbs, which are 9, and from it the total selections are 6. Okay, so what are the remaining one? We have here K. So K is what? K is 5. Okay, so 5 are basically the tulip bulbs. So let me write them here. So writing them here, the total number of, or let me write them here. Let me move down somehow. Okay, so it is what? The total number of combinations here are, this is N, choose N. So 9, choose 6. Okay, the other ones are from K, I have to select X. So 5, choose 4, which are basically from 5 tulip bulbs, I have to select 4 tulip bulbs, which are here, and the other ones here are what? The other ones here are N minus K. So N minus K is 9 minus 5 is 4. Okay, and these are the 4 daffodil bulbs, and from them I have to select what? N minus X. So 2 daffodil bulbs. Okay, so 2 daffodil bulbs are here. So it will be the combination formula, and finding out the answer from it, what we will get? It will be the 5 factorial divided by 4 factorial multiplied by 1 factorial, the upper one. Okay, then 4 factorial divided by the 2 factorial and 4 minus 2 factorial. So it is again 2 factorial divided by this one. So 9 factorial divided by 6 factorial. 9 minus 6 is 3 factorial. Okay, so finding the answer of it, what we will get? The answer of it is 5 divided by 14, and that is what? That is basically the solution of our question. Okay, so that's it for today, in which we have seen the solution of question 5.29. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.30, and the statement of this question is: to avoid detection at customs, a traveler places 6 narcotic tablets in a bottle containing 9 vitamin tablets that are similar in appearance. If the custom officials selects 3 of the tablets at random for analysis, what is the probability that the traveler will be arrested for illegal possession of narcotics? Okay, so first of all, let me write the given data here. Okay, so the given data here, we can very easily see here that the narcotics or N are 6 and vitamins are 9. Okay, so these two are combined together, and we have got 6 plus 9 equal to 15. Okay, so these are the number of tablets. When it has been reached to the custom officer, he will do what? He will select 3 out of them. Okay, so if any one of them is the narcotic, okay, if any one is X is greater or equal to 1, okay, so the person will be arrested, because those would be the narcotic. Those tablets can be 1, 2 or 3, if any one of them is narcotics, so he will be arrested. Okay, so we want to find out what? We want to find out the probability that the number of tablets selected would be greater or equal to 1, and this is what? This is also 1 minus the probability that none of the narcotic tablet is selected out of these three. So we can also have this one as well. Okay, so this is the main equation for this question, and let me call it equation A. So now here we have to find what? We have to find x equal to 0 as well. But how to find it out? What is the probability distribution and what is the formula which we have to use? So here we can again see that we have two clauses, and these are combined together. We know the total number of items here as well and the selected number of items here as well. So here let me write them. So this is what? This is the total number of items. This is what? These are basically the selected number of items, and these are the items which are available here. In order to find x equal to 0, it should be the no narcotic item here. Okay, so for that we have to do what? We will have all the items here which would be n, choose small n, so those would be out of 15, 3 are selected. Okay, and similarly from the narcotic, which are 6, none is selected, and from the vitamin, which are 9, all 3 are selected. Okay, so this is what? This is basically the hypergeometric probability, and here we can also write it in the formulation. It is what? This is k, this is x, this is n minus k, this is small n minus k. Okay, and this is and this is small n, this is h, okay, x and small n, and here this is k. So this formulation would be what? This formulation would become h, okay, 0 the value of x, 15 the value of n, 3 the value of small n, and k, which is here 6, this is the value of k. So we have to find it out and then put all these values here. So when it will be calculated, the output of it, what we will get from here, it would be 84 divided by 455. Okay, or simplifying them, we will get what? It will be 12 divided by 65. So this is what? This is for the x equal to 0, and this is for this one, and this is the value of it. But initially we have also seen that this should be subtracted from 1 as well, so it would be 12 divided by 65, which is for this value. So it would be 65 minus 12 divided by 65, so it would be the 53 divided by 65, and that is what? That is basically the solution of question 5.30, because we have seen that how to formulate the strategy for finding out the required quantities, and this is by using this formula, okay, for the value of x 0, and this is by this, because this is the hypergeometric probability distribution. Okay, you know the formula, and you have also seen that what are the scenarios where we can employ this distribution to find out the probability whatever we want. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.31, and the statement of this question is: a random committee of size 3 is selected from 4 doctors and 2 nurses. Okay, so 2 nurses and 4 doctors write a formula for the probability distribution of the random variable x representing the number of doctors on the committee, and in the second part find p of x is greater or equal to 2 and less than or equal to 3. Okay, so in the given data, what are we given here? Okay, so the random number of items here are, let me call them 3, and we have doctors D equal to 4, total doctors and nurses NUR, these are equal to 2. Okay, these constitutes a total number of items, which is what? Which is 4 plus 2. So this constitutes the total number of items, which is 4 plus 2 equal to 6, and this is what? This is n. So we have all of these items. This D is equal to 4. So from it, first part is write a formula for the probability distribution of the random variable x representing the number of doctors on the committee. So let me solve it first. Solving it, and here we have to find the formula for the number of doctors. So here the total number of doctors here we have are 4, and if I want to select the k number of doctors from it, it will be 4, choose k. Similarly, the number of nurses here are 2. Okay, so the remaining number of items here will be the total number of items what I want to choose, and subtracting from it the number of doctors chosen. Okay, so the total number of items I want to choose are 3, and from it I have to subtract the number of doctors, so it would be this one. Okay, and I have to divide it over the total number of items. So the total number of items here are n, choose small n, and choose small n. Okay, or writing their values, let me write their values. So it would be 6, choose 3. Okay, so this is for what? This is for k, and it is the probability that x, which is basically what? Which is basically the number of doctors, it is equal to k. Okay, so this is what? This is the solution for part A of this question. Similarly, in part B, I have to find the probability that x is greater or equal to 2 and less than or equal to 3. Similarly, I have to find out the value of x is greater or equal to 2, less than or equal to 3, as the both of these items are here and available in it because of this equality sign. So it can be x is equal to 2 plus probability that x is equal to 3. Let me write these values. For them, I have to use the formula which is here. Okay, this formula. So here writing the values. So it would be for the first one, it would be for 4, choose 2, and here 2, choose 3 minus 2. So it would be 3 minus 2. So it would be 2, choose 1 divided by the 6, choose 3. Okay, similarly for x equal to 3, I will have 4, choose 3, and here it would be what? It would be 2, choose 0 whole divided by 6, choose 3. Okay, so let me move down somehow, taking the LCM here. So in this LCM we will have this overall, so it would be 6, choose 3, and here we will have 4, choose 2, 2, choose 1, plus 4, 3, 2, 0. Okay, solving it, I will get here, let me move down somehow more, it will become 4 factorial divided by 2 factorial into 2 factorial multiplied by 2 factorial divided by 1 factorial, and 2 minus 1 is again 1 factorial, plus 4 factorial divided by 3 factorial and 1 factorial multiplied by 2 factorial divided by 0 factorial and 2 factorial, because 2 minus 0 is 2. Similarly, whole divided by 6 factorial divided by 3 factorial, and 6 minus 3 is again 3 factorial. Okay, so let me solve it, and solving it, it will be 4 multiplied by 3 is 12. 12 divided by 4, so it would be 3 multiplied by 2. Okay, plus it is what? It will be 4 multiplied by 1, so it will be 4 divided by, here it will become what? It will be 6 multiplied by 5 multiplied by 4 multiplied by 3 factorial, whole divided by 3 into 2 multiplied by 3 factorial. These two will cancel out. It is 2 to 4. It is 3 to 6. So it will be 20. Okay. So it will become 3 to 6, 6 to 12. 12 plus 4 is 16 divided by 20. Okay. So it would become 4 by 5, which is what? Which is basically the solution of our question. So let me move offside. Okay, so the answer of it is 4 divided by 5, and this is what? This is the solution of this one. So that's it for today, in which we have seen the solution of question 5.31. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. This is question 5.32, and the statement of this question is, from a lot of 10 missiles, 4 are selected at random and fired. If the lot contains 3 defective missiles that will not fire, what is the probability that A, all 4 will fire, and B, at most 2 will not fire? Okay, 4 fire will means all 4 are not defective. Okay, so this is what we have. Now let me first write the given data here, and in given data we can very clearly see here that the total number of missiles here are 10, and the selected number of missiles which are selected at random from these 10 missiles are small n, and that is equal to 4. Okay, from here it is already known that the defective number of the missiles are 3, and non-defective or ND are, these are 10 minus 3, these are 7. Okay, so in solving it, in part A all 4 will fire. What does it mean? Let me solve them here, and in part A we have to write that all 4 will be selected from these things. Okay, so all 4 will be from it, and there will be none of them. So therefore it is what? It will be 7 choose 4, because all 4 will be from this 7, and from this 3 there will be none, and also the total number of items where will be, and choose small n, so it would be 10 choose 4. Okay, so this is what? This is the equation for the hypergeometric probability distribution, and for it I can see that here I have to select these 4 items, and these are from total number of n, the selected number of items 4, and the k value here is 7. Okay, so this is what we have. Let me solve it. So it would become 7 factorial divided by 4 factorial into 3 factorial. 3 choose 0 is already known, and that is 1, and also this one 10 factorial divided by 4 factorial into 6 factorial. Okay, so let me solve it. So 7 factorial is 7 multiplied by 6 multiplied by 5 multiplied by 4 factorial whole divided by this 4 factorial, okay, multiplied by 3 factorial is 6. Okay, this will cancel out with this one, this with this one, so it would be
35, and this one here, when you calculate it, it would be 210. So it would be 35 divided by 210, and solving it, it will give me 1 by 6. So answer of it is 1 by 6. Okay, so the probability of for part A of my question is 1 by 6. Similarly, in part B, let me solve it here. In part B, I have to solve that at most 2 will not fire. So I have to find the probability that the not firing items here are, or the non firing missiles here are, less than or equal to 2. Okay, so I have to find them out, and here it is what, this is less than or equal to this one, and let me solve for it. It would become what, let me give it a value k equal to 0 up to 2. All of these values are included. So let me write here all the not firing missiles. So these are 3, or D. Okay, so these are 3, and from it I have to sample the k number of items. Okay, the remaining ones here are which are working are 7, and here we will have the remaining items. So the selected items are 4, and if k are selected here, the remaining items will be here, and also divided by 10 choose 4, which is already known, and that is calculated as 210. Okay, so it will become what, let me calculate them for all the values. So all the values here, let me move down somehow. For all the values here, it would become 3 choose 0, and here it would be 7 choose 4 for the value of 0, 210, plus for k equal to 1, 3 choose 1, 7 choose 3, whole divided by 210, plus 3 choose 2, and 7 choose 4 minus 2 is 2, divided by 210. Okay, so once it will be calculated and all the values will be found out, it would be 29 by 30, which is what, which is the solution of part B of my question. Okay, so that's it for today, in which we have seen the solution of question 5.32. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.33, and the statement of this question is, if 7 cards are dealt from an ordinary deck of 7 to 2 playing cards, what is the probability that A, exactly 2 of them will be face cards, B, at least one of them will be a queen? Okay, so the given data here, okay, again here the total number of cards are 52. Okay, from which we will have to sample 7 cards. Okay, in part A of it, we have to see that exactly 2 of them will be face cards. Okay, so in part A, let me use this black color for it. In part A, I have to see that exactly 2 are face cards. Okay, so how many face cards are in cards? So there are basically 4 jack cards, 4 queen cards, and 4 king cards. So in total they would be 12, which are basically face cards, or these are also card court cards or face cards. Okay, so there are 12 cards, and from those 12 we should have 2. Okay, and also the remaining cards are 40, because 40 plus 12 are 2, and from these 40 the remaining cards would be 7 minus 2, which are 5. Okay, so these are what we have. So let me arrange them as well. From the 12 face cards, I have to choose 2 cards, and from the remaining 40 cards I should have 5. Okay, so here again this is the problem of the hypergeometric probability, where what we will have, the face cards are 12, and from those 12 I have to select 2. Okay, the remaining cards are 40 and from them I have to select 5. Okay, while dividing it over the total number of cards, which are 52, choose 7. Okay, so this is what this is: h of 2, 52, choose 7, and then 12. Okay, so this is what we have here, and when we will solve it, the answer of it will be what? The answer of it will be 0.3246, and that is what, that is basically the solution of part A of my question. The only thing here is the understanding of it. Okay, and from it we have to understand this one, and then it will be easy for us to solve it. Now part B of my question, let me move down somehow. In part B of my question, I have to see that at least one of them will be a queen. So I have to see the probability that if x are basically the number of queens, so at least one of them will be queen. It will be greater or equal to 1, which can also be written as 1 minus probability that queen is 0. Okay, no queen will be here, so therefore it can be written as what? How many queens do we have here? We have 4 queens, and we, if x is equal to 0 or no queens, so from 4 we should have no queen. Okay, the remaining cards here are 52 minus 4, so those would be 48, and from 48 I have to select all the cards which are 7. Okay, and dividing it over the total number of cards which are 52, choose 7. Okay, so it would become what? It would become 1 minus 4, choose 0 is 1, so it would become 48, choose 7 whole divided by 52, choose 7. Okay, so the answer of it would be 0.4496, and that is what, that is basically the solution of part B of my question. Okay, so we have seen the solution of question 5.33, in which the solution is related to the hypergeometric probability theory. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is chapter 5, and today we are going to solve question 5.34 and 5.35. Both of these questions are closely relevant and related to the hypergeometric probability distribution. So let us first start with question 5.34. So the statement of this question is, what is the probability that a waitress will refuse to serve alcoholic beverages to only 2 minors if she randomly checks the IDs of 5 among 9 students, 4 of whom are minors? Okay, so let us first indicate here that what is the given data. Here she has to select 5 students out of 9, so here this is capital N, out of which she has to select 9. Okay, and also the minor students here are 4. Okay, so if 2 of the 5 are basically the minors, she will reject alcoholic beverages. Okay, so in solving it, let me solve it first. So this is 5.34, and in solving it, we have to do what here? First of all, we have to write the 4 minor students, and out of those 4 she has to select 2. If 2 of them are basically the minors, okay, what will she do? She will reject the alcoholic beverages. Similarly, the remaining students from 9 are basically the adults. Okay, and she will select 5 of them, so 3 will be from the adults, and similarly the total selections here would be 5 out of these 9. Okay, so it is what? It is basically the hypergeometric probability distribution, and here I have to select 2 from 9, 5. Okay, and here 4 as well. Okay, so let me solve it. When I will solve it, the answer of it will be given, and the answer of it will be what? 60 divided by 126, or 10 divided by 21, which is equal to 0.47, and that is what? That is basically the solution of question 5.34. Similarly, in solving question 5.35, the statement of it is a company is interested in evaluating its current inspection procedure for shipment of 50 identical items. Okay, so the identical items are 50. The procedure is to take a sample of 5 and pass the shipment if no more than 2 are found to be defective. What proportion of shipment with 20% defective will be accepted? Okay, so if the 20% items are defective here, so the total number of items here are 50. Okay, and a person has to select what? 5 items from it. So with 20% defective items, 50 multiplied by 20% is 20 divided by 100. So it is what? This will cancel out, and those would be the 10 items. So the 10 defective items will be selected. Okay, there will be 10 defective items from it. So n is 50. There will be 40 undefective items and 10 defective items. Okay, from it a person will select 5 items, and if more than 2 are defective items, okay, so what will happen? The shipment will be rejected. Okay, so the defective items must be less than this 2. So let me solve it now, and I think the problem is now clear to you guys because of this diagram here. So in order to solve it, let me here choose this color, and here in order to accept it, the probability of acceptance is what? We will have all the items x from 0 to 2, and all of these items will be what? Will be from the defective items, which are 10. Okay, and the remaining items here are 40, and all the other items were from it, so it would be 5 minus x. Okay, and whole divided by what? Whole divided this 55. Okay, so what will happen here? Let me write it here. So it will become 10, choose 0, 40, choose 5, whole divided by 50, choose 5. Okay, similarly plus this one now 1, 10, choose 1, 40, choose 4, whole divided by 50, choose 5. Okay, also here let me expand it, because here we have from 0 to 2. Also here 10, choose 2, 40, choose 3, whole divided by 50, choose 5. Okay, so now when I will solve it, the answer of it will become 0.95 is the answer of our question. After solving it, we will see that this is the solution of our question. Okay, so that's it for today, in which we have seen the solution of 2 questions which are related to the hypergeometric probability distribution. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.36, and the statement of it is a manufacturing company uses an acceptance scheme on items from a production line before they are shipped. The plan is a 2-stage one. Boxes of 25 items are ready for shipment, and a sample of 3 items is tested for defectives. If any defectives are found, the entire box is sent back for 100% screening. If no defective are found, the box is shipped. Okay, so on the basis of it, let me first write that what is given here. So the total number of items here are 25, and from these 25 a person has to select 3 items. Okay, so according to this statement, if any of these 3 is found defective, what will happen? Entire box is sent back for 100% screening, so send back. Okay, also if none is defective, it will be shipped. So what is this? This is the entire statement. So on the basis of it, part A of our question is, what is the probability that a box containing 3 defectives will be shipped? And in B, what is the probability that a box containing only 1 defective will be sent back for screening? Okay, so I think these statements are now clear. Let me solve it. And in solving part A of our question, we can see that here, if we have the defective items in the lot are 3, okay, what is the probability that it will be accepted for shipment? Okay, so what will happen here? I have to use what? I have to use the hypergeometric probability distribution, because now I have the number of items here. So first of all, let me write the total number of combinations. So from 25, 3 items should be taken. 25 choose 3. These are the total number of items or the combinations which has to be taken from these 25 items. Similarly, if 3 defective items are present in it and it is accepted for shipment, it means that none of these 3 items is selected here. So means 3 are available in the 25 while none is selected within the scrutiny time. Okay, similarly, the remaining items were 22 which were non-defective, and all the 3 items were selected from these 22. Okay, so this is what, this is basically the formulation of the problem for part A, and this is what, this is H0 from 25 3 and K is also 3. So from it I have to select all this. So let me solve it, and this would become what? It would become 1. This is 1. So let me write the other important stuff. So it would be 22 factorial divided by the 3 factorial, and 22 minus 3 is 19 factorial, whole divided by 25 factorial, whole divided by 3 factorial, and 25 minus 3 is 22 factorial. Okay, so when solving it, the answer of it will become 77 divided by 115. You can solve it and you can see that the answer will be here. So this is what, this is the solution for part A of our question. Okay, so I think you have understood all the things which we have done here. In part B of our question, what is written? What is the probability that a box containing only 1 defective will be sent back for screening? A box now contains only 1 defective item, and in scrutiny time that defective item will be selected and the entire box will be sent back. So this is part B. And here now the defective item is only 1. Okay, so again using the hypergeometric probability distribution, so here the total items are again 25, choose 3. Okay, now the defective items are 1, and during the scrutiny only that defective item is selected. The remaining items here are 24 which are non-defective, and 2 out of them are selected. Okay, so this is what, let me write the hypergeometric formulation for it. It is 1 from 25 3 and K is also 1. Okay, so this is what we have here. Again this one will be 1 as well, and solving it again it would become 24 factorial divided by 2 factorial multiplied by 22 factorial. Okay, because 24 minus 2 is 22, and also here it will be the same one as it is, so it would be 25 factorial whole divided by 3 factorial multiplied by 22 factorial. Okay, so solving it at the end, what we will get, it would be 3 by 25, and that is what? That is basically the solution of part B of our question. Okay, so that's it for today, in which we have seen the solution of question 5.36. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.37, and the statement of it is: suppose that the manufacturing company of exercise 5.36 decides to change its acceptance scheme. Under the new scheme, an inspector takes one item at random, inspects it, and then replaces it in the box. A second inspector does likewise. Finally, a third inspector goes through the same procedure. The box is not shipped if any of three inspectors find a defective item. Answer the questions in exercise 5.36 for this new plan. Okay, so let me first paste it here, exercise 5.36, and we have to see that what has been asked in that question. So let us paste 5.36. So this was exercise 5.36, in which we had the total number of items equal to 25, and out of them 3 were selected. But now, as the strategy has been changed, but we have to answer these part A and part B. Okay, so first of all, let us see that what is the strategy here which has been passed. So let us have 3 inspectors here. Okay, these are the 3 inspectors, 1, 2, 3. To each one of them, a carton containing 25 items. The first inspector will receive a bag containing 25 items. He will select only one of these 25 items, will check it and forward it to the second inspector if it is non-defective. Otherwise, what he will do? He will send it back. Similarly, what he will do during the forwarding time, he will place back the item which he picked, and then he will forward it to the second inspector. The second inspector now will receive 25 items. What he will do, he will again a single item randomly from these 25 items, will check it, and if that is undefective, he will place it back in the bag and forward it to the third inspector. If that item which he picked is defective, what he will do, he will send it back and will not forward it. Okay, the third one will again get the 25 items. He will again pick a single item randomly from it and follow the same procedure. What he will do, he will check it. If that item is undefective, he will ship it. Otherwise, he will send it back and will not recommend it for shipping. So that is the overall procedure which will be followed here. So in order to solve it, let us have part A. What is the probability that a box containing 3 defective items will be shipped? Okay, so a box containing 3 defective items would be if the total number of items are 25 and 3 are defective. So the undefective items are 22. Okay, to each one of them, the probability of selecting the undefective item would be 22 divided by 25, due to the probability theorem that the probability here will be the number of items divided by the total number of items. So here he will get it. So the probability of getting it here would be 22 by 25. This is what? This is the probability of acceptance. Similarly, when the item will be put back, the same probability will be followed here. Okay, and the same will be followed here as well, because this is the sampling with the replacement in each of the step. Okay, so I hope you have got it. Now, in order to combine them all, we can see that this each one of them here has been doing the sampling with replacement and independently. Okay, so here I have to multiply them together. So multiplying them together, what I will get, we will get 22 by 25 whole cube, and from it what will we get here? Calculating it, we would get 10,648 divided by 15,625. So the answer of it would be 0.68 38. Okay, so that is what, that is the solution of part A of my question, which is the probability that a box containing 3 defective will be shipped. In part B of my question, what is the probability that a box containing only 1 defective will be sent back for screening? Okay, so let me move down somehow. Again, following the same procedure here, if it will contain only 1 defective item, so the undefective item would be 24. So the probability of passing through here would become what? For part B, it will become 24 by 25. From here, it would again be 24 by 25 because the sole principle remain the same. And here it will again be 24 by 25 because this is the probability of passing through all of them. Okay. So what we will get from here, it would become 24 by 25 whole cube. Okay, so this is the probability that if a box contain only 1 defective item, it will be shipped, okay, or pass through all of these 3 inspectors. But the question here is that if what is the probability that a box containing only 1 defective item will be sent back for screening and will not be shipped? So it will be what, which is the opposite of it, and it would be 1 minus 24 divided by 25 whole cube. Okay, finding it out, what will we get? It will be 1801 divided by 15,625, and the answer of it would be 0.1153, and that is what, that is the solution of part B of my question. Okay, so I hope you have understood all the solution and what do we have to do, and that is what, that is basically the solution here we have. So that's it for today. If you have any question, you can put it in the comment box and I will answer those questions. See you soon. Welcome guys, this is question 5.38 and the statement it has is, among 150 IRS employees in a large city, only 30 are women. Okay, 150 are the total employees and 30 of them are women. If 10 of the employees are chosen at random to provide free tax assistance for the residents of the city, use the binomial approximation. Okay, we have to keep it in our mind, to the hypergeometric distribution to find the probability that at least 3 women are selected. Okay, so let me first write the given data. Okay, in a city we have a total employees 150, out of them 30 are women. Okay, and now out of these 150, 10 are randomly selected. Okay, so this is what, this is clearly the case of the hypergeometric distribution where 3 women has to be selected. So now in order to find out here the probability that x is greater or equal to 3, if x is a random variable which is basically the number of women out of these 10, it can also be written as 1 minus the probability that x is less than 3. Okay, then in order to find out this probability, what we can do, we can write here x is less than 3. For it, all the less than 3 values would be the probability that x is equal to 0 plus the probability that x is equal to 1 plus probability that x is equal to 2. Okay, these are all the values. Then it can be written as, if I write this as x equal to 0 up to 2, okay, this is the small x, it can be written as probability that x is equal to small x. Okay, this is what we have. Now let me proceed it by going somehow downwards. Okay, so it is what I can very easily write here, the hypergeometric probability distribution. From it, the total number of items are 150. out of them 10 are selected. Okay, then if I want to find out the number of women out of these 10, the number of women from in the total number of items are 30. From it, if I have to select the items which are X, it would be here. Add the remaining items which are the men are 120, and the remaining item would here become 10, which are the total number of selected item minus the number of women which are selected, and it would be for what? It would be for all the values from 0 to 2, and this is what? This would be the probability that X is less than 3. Then taking this value, putting it here, we can find our solution. Okay, this is by using the hypergeometric probability distribution, but the question and the scenario here is that this would be a very huge number, because here you can see that this is a number very huge, this one will be very huge, this one also be very huge, so it wouldn't be computationally very feasible to find it out. So despite it, what we can do here is that, as given in this question, we can use binomial distribution approximation. Okay, so in order to do the binomial distribution approximation, what we have to do, out of this we have to find the probability of X, which is the P, the probability of women in the number of employees. So it would be 30 divided by 150, so it would be 0.2. Now this is the probability of the women out of this 150, which is the population size. Now out of this population, we have selected this sample, and out of these samples I have to find out the probability that women selected are at least 3. So again here we have, this is the probability which is given, the number of items here now we have 10, while the values of K would be 0, 1 and 2. Okay, we have to find them out and then subtract them from 1. So it would be the probability that X is greater or equal to 3. It would be 1 minus the probability that X is greater than 2. Using the binomial probability, what we can write here, it would be the binomial, okay, where the values of K will be here, and also the number of samples are 10 and the probability is 0.2. Okay, so let me solve it for this case, and it is probability that X is greater or equal to 3. So let me solve it by going downwards. Okay, so here we have, so this is what? This is the probability that X is greater or equal to 3. So it would be 1 minus this binomial. So writing it here, it would be for X is equal to 0 up to 2, and it is what? It is 10, choose X. Okay, and then the probability which is 0.2, taking it, writing here X, and 1 minus 0.2, 10 minus X. Okay, so let me write these values. It would be for all the values of X, it would be 10, choose 0. For the first one here, it would be 0.2, 0 and 0.8, 10. Okay, plus, let me use it like this. Similarly, 10, choose 1, 0.2, 1 and 0.8, 9, because this is 10 minus 1 is 9. Okay, similarly the last one, 10, choose 2, 0.2 raised to power 2 and 0.8, 10 minus 2 is 8. So this is what we will find. So after finding it out, subtracting it from 8, what we will get, it would be 0.3 to 3. Okay, so that is what, that is basically the solution of our question. From this question and from this you can also find out the similar solution, but it wouldn't be that much computationally easier as we have done it here. Okay, so that's it for today, in which we have seen the binomial approximation for the hypergeometric probability problem. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is chapter 5 and today we are going to solve question 5.39, 5.40 and 5.41 due to the very high relevancy of these three questions. So let me first go through the statement of the question 5.39. An annexation suits against a county subdivision of 1200 residents is being considered by a neighboring city. If the occupants of half of the residence object to being annexed, what is the probability that in a random sample of 10 at least 5 favor for the annexation suit? Okay, so the annexation probability here is this. Okay, let me first write here the solution for this question, and here writing the probability of annexation here, this is what, this is half of the residence, so it would be 0.5. Okay, we know that, and the total number of residences are here 1200. So now we know what, we know that 10 are sampled, and out of those 10, 3, at least 3 favor the annexation. Okay, so here the number of samples are 10, and I want to find out the probability that X, which are the people in favor of the annexation, are greater or equal to 3. This would be 1 minus the probability of X less than 3. Okay, so this is what, this is clearly the binomial probability theorem, in which we have all of this, and here we will do what, we will basically use the binomial approximation. Okay, we want to do it. So in order to do the binomial approximation, here it would be what, it would be 1 minus, this is the probability that X is less than 3, so it would be, let me write here this K, it is from 0 to 2, all the values are less than 3, and using the binomial theorem here, which is the N choose K, so here N is 10, so choose K is here. Okay, the probability of annexation is P, which is 0.5 and raised to power K, and 1 minus 0.5, 10 minus K. Okay, so let me use this one as well, and here it would become what, it would be 10 choose 0, 0.5 raised to power 0 is 1, and it would be 0.5 this power, sorry, this is K. Okay, so it would become 10 minus K, so it would be 10. Similarly, for the value of K equal to 1, it would be 10, choose 1, 0.5 raised to power 1, and here 0.5, 1 minus 0.5 is 0.5, this is 9. Okay, and the last one here would be 10, choose 2, 0.5 raised to power 2, and 0.5 raised to power 8. Okay, so that is what we have. After finding it out, all of them, and then subtracting it from 1, what would I get here? It would be the probability that X is greater or equal to 3. It would be 0.945, and this is what, this is basically the solution of question 5.39, and you have seen that this is basically the usage of binomial approximation, which has been by this formula. Okay, so that is for question 5.39. So let me remove it, and now let me move to question 5.40. It is estimated that 4,000 of the 10,000 voting residents of a town are against a new sales tax. Okay, so here the total number of voters and the number of voters which are against the tax are given here. So from it we can write the probability. So it would be 4,000 divided by 10,000. Okay, so it would be word 4 by 10, so it would be 0.4. So this is basically the probability that the random person is against the sales tax policy, and the probability that a person is proponent of the tax policy, that would be 1 minus p, and this is 0.6. From it we have deduced it. If 15 eligible voters are selected at random and asked their opinion, what is the probability that at most 7 favor the new tax policy? So again here n is what? And is 15, and here we have to find that what is the probability that at most 7 favor the tax policy, means the 7 are proponent of the tax policy. So at most 7 means I want to find out the probability that if x is the number of people which are in favor of the new tax policy, so we have to find this one. Okay, so this is what we want to find out. So in order to find it out, what we can do, again we have here the probability of the favor and we have the total number of people here as well. So what we can do in order to find it out, this one can be very easily found out by k equal to 0 up to 7, because this is up to 7, and here writing the n which is 15, choose k. Okay, so now as we want to find out the people who are in favor of the tax, so this is the probability we have. So this is 0.6 raised to the power k, and 0.4 which is 1 minus 0.6, that is 15 minus k. Okay, so that is what we want to find out. So then we have to do what? We have to calculate it out, and after calculating it, the answer of it would be 0.2131, and that is what? That is the probability that x is less than or equal to 7, and that is what we wanted to find out here. Okay, so that is what, that is basically the solution of question 5.40. So this is what we have done. So in question 5.41, a nationwide survey of 17,000 college seniors by the University of Michigan revealed that almost 70% disapprove of daily pot smoking. Okay, so here the probability of the disapproval of daily pot smoking is 0.7, which is visible from this 70% figure. If 18 of these seniors are selected at random, means the total number of items are 18, okay, and ask their opinion, what is the probability that more than 9? Okay, so we want to find out the probability that the x, which is the number of college seniors, is greater than 9, which is greater or equal to 10, and fewer than 14 disapprove of smoking the pot, means less than or equal to 13. Okay, we want to find it out. Okay, so this is the similar type of problem, and here in order to find it out, we can write what? We can start k from 10 up to 13. Okay, the number of items here are 18, choose k. Okay, and the probability is already given. This is 0.7 raised to the power k, and also 1 minus 0.7, that is 0.3, and 18 minus k. Okay, so what we have to do after it, we have to expand it. So let me expand it. Expanding it, we will get 18, choose 10. Okay, 0.7 raised to power 10 multiplied by 0.3 multiplied by 18 minus 10 is 8. plus the second one is after 10 we have to have 11. So 18 choose 11 and 0.7 raised to power 11 and 0.3 raised to power 11 minus 18 minus 11 is 7 plus after 8 18 choose 12 0.7 raised to power 12 and 0.3 raised to power 18 minus 12 is 6. Okay, and the last one here would be, let me move down somehow or here. Okay, so the last one here would be 18 choose 13 and probability is 0.7 choose 13 and 0.3. 18 minus 13 is 5. Okay, so we have to do what? We have to add them all. Okay, we have to add all of them. Okay, adding them, what will be the answer? 0.6077, and this is what? This is basically the probability that x is greater or equal to 10 and less than or equal to 13, and that is what? That is basically the solution we wanted to find out. Okay, so that's what we wanted to find out, and that is basically the solution of question 5.39, 40 and 41. And in all of these questions we have seen what? We have seen the application of the binomial approximation. So that's it for today. If you guys have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 5.42, and the statement of this question is find the probability of being dealt a bridge hand of 13 cards containing 5 spades, 2 hearts, 3 diamonds and 3 clubs. Okay, so this is what? This is the given statement of my question, and here the given is if a person chooses 13 cards, what is the probability that out of those 13 cards he will have 5 spades, 2 hearts, 3 diamonds and 3 clubs. So you can count them, and it would be 3 plus 3 is 6, 6 plus 2 is 8, 8 plus 5 is 13. Okay, so we have to find the probability of this combination. Okay, and in total cards, the total number of spades are 13, the total number of hearts are 13 as well, 13 diamonds and 13 clubs as well. Okay, adding them all together it is 52. So from the 52 we have to select 13 cards, and what is the probability that out of those 13 cards we will have 5 of this, 2 of heart, 3 of D and 3 of C. Okay, so this is clearly the hypergeometric probability problem. And here, first of all, what do we have to do in all of these problems? What do we have to write? In the denominator we have to write the total number of cards, from it the chosen number of cards. So total number of cards here are 52, from which I have to choose 13. Okay, and the first combination is the spades and the total number of 13 spades. Similarly, second one are hearts, 13 are hearts. Third one are the diamonds, 13 diamonds, and the last one are this club, so 13 clubs as well. So out of them I have to select what? Let me use this color. From 13 I have to choose 5. Out of these 13 hearts we have to select 2. Then 13 diamonds we have to select 3, and from 13 clubs we have to select 3 as well. Okay, so solving it, let me move down somehow. Solving it, we will get 13 factorial divided by 5 factorial. 13 minus 5 is 8 factorial multiplied by the 13 factorial divided by 2 factorial, and 13 minus 2 is 11 factorial multiplied by 13 factorial divided by 3 factorial. 13 minus 3 is 10 factorial multiplied by 13 factorial divided by 3 factorial multiplied by 13 minus 3 is 10 factorial as well, divided by the overall combinations here, which would be 52 factorial whole divided by 13 factorial, and 52 minus 13 is 39 factorial. Okay. So solving it and then finding the answer of it, what we will get 0.0129, and that is what? That is basically the solution of our question, what we were solving in this video. So that's it for today, in which we have seen the solution of question 5.42, in which we had to select the categories of the items from the total of 4 categories, and that is what we wanted to solve in this question. If you have any question, you can ask in the comment box. See you soon. Welcome back, guys. This is question 5.43, and the statement of this question is: a foreign student club list as its 2 Canadian, okay, 3 Japanese and 5 Italians and 2 Germans. If a committee of 4 is selected at random, find the probability that A, all the nationalities are represented, B, all nationalities except Italian are represented. Okay, so first of all, let me write here the given data. What is given here? So the nationalities we have here are Canadian, okay, Japanese, okay, Italian, and the last one is German. Okay, so the number of Canadians are 2, the number of Japanese are 3, the number of Italians are 5, and the number of Germans are 2. So the total number of the members are 2 plus 3 plus 5 plus 2. So this is equal to 12. Okay, so the 12 number of total members. So from it, what do we have to do? We will select the out of them and it, we have to select at random 4 members. Okay, 4 members have to be selected, and on the basis of it, we have to solve part A and part B. So in part A, this is, let me call this solution. In part A, we have to see that all nationalities are represented, means in these 4 members, all the members are from Canadian, Japanese, Italian and German. So therefore each one will be represented, and a person from each of these nationalities will be selected, which are 1, 1, 1. Okay, so therefore it is the similar hypergeometric probability problem, and here we have to divide it over the total number of elements, which are what? Which are from the 12 we have to select 4, which are the total number of the selections, and then we will have what? We will have the Canadians. Okay, we will have the Japanese. Canadians are 2, Japanese are 3, Italians are 5, and Germans are 2. Okay, from each of them we must have 1, 1, 1, 1. So 1 plus 1 plus 1 plus 1, these are 4 which are here as well. Okay, so let me solve them here. So solving it, it will become 2 factorial divided by 1 factorial. So it will be 2. Okay, it will be 2 multiplied by this 3 multiplied by 5 multiplied by 2. You can solve it and you will see that it will be 2, because 2 factorial divided by 1 factorial divided by 2 minus 1 factorial is 2. Okay, so and so on. You can solve them and you will see that these will be this one. And similarly here, it will be 12 factorial divided by the 4 factorial multiplied by 12 minus 4, 8 factorial. Okay, solving them, what we will get, the answer of it will be 4 divided by 33. So that is what, that is basically the solution of part A of my question. Okay, in part B, all nationalities except Italian are represented. Okay, so if none of the Italian will be selected, we can very clearly see here that the number of Italians here are 5. Okay, the 5 Italians we have, and from them we don't want to select anyone, so therefore it will be 5 factorial divided by 0 factorial, and 5 minus 0 is 5 factorial, so these will cancel out. 0 factorial is 1, so therefore the answer of it will be 1. Okay, solving the remaining part of it, what do we have to do? Here we have all of these items, and here this is the B, and in selecting the remaining items from Italian, I have to select the 0, and then from we will have Canadian, Japanese, and Germans. Okay, we have to select them in such a way that the total number of the members here are 4. Okay, so in how many ways can we do it? It can be 2, 1, 1, 2 Canadian, 1 Japanese, 1 German. Okay, this is the one combination. Similarly, we can have here 1, 2, 1. We can add them and we will see that this will be 4, and also we can add them like 1, 1, 2. Okay, so these are what? These are basically the 3 combinations: 2 Canadians, 1 Japanese, 1 German, or 1 Canadian, 2 Japanese, 1 German, or 1 Canadian, 1 Japanese, and 1 German. So these are basically the combinations which can be adopted if the Italians are not included. So therefore, adding them here, what we can get here again, using the hypergeometric probability distribution, the Canadian total number of Canadians are 2 for the first combination, the Japanese are 3, and also Italians are none, and Germans are 2. Okay, for the first combination we have 2, 1, 1, so therefore we will write 2, 1, 1 whole divided by the total number of combinations, which are the similar one as it is. Okay, so it will be 12 choose 4. Okay, or we can have this combination as well. Okay, we can have this one as well. So writing it here again, the total number of Canadians are 2, the total number of Japanese are 3, the total number of Germans are 2. Okay, from it now I have to select 1 from the Canadian, 2 from the Japanese, and 1 from the German. Okay, and whole divided by the 12 choose 4. Okay, this is what we have, and plus here. So let me move here as well. Okay, this one, and now we can see here that again we have this third combination 1, 1, 2. Here the total number of Canadians are 2, the total number of Japanese are 3, and the total number of Germans are 2 as well. Writing the combination 1, 1, 2, so 1 from the Canadian, 1 from the Japanese, and 2 from the German, whole divided by what? 12 choose 4. Okay, so we have to do what? Let me calculate it, and calculating it and then adding them all, we will have here this overall, this LCM, and then writing them all here 2, 2, 3, 1, 2, 1 plus 2, 1, 3, 2, 2, 1 plus 2, 1, 3, 1, and 2, 2. Okay, solving it, let me move down somehow. So solving it and then writing the answer of it, it will be 8 divided by 165, and that is what
That is basically the solution of part B of my question. Okay, so that's it for today, in which we have seen the solution of question 5.43. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.44, and the statement of it is an urn contains 3 green balls, 2 blue balls and 4 red balls. Okay, so first of all, let me write the given data. In an urn we have green balls, blue balls and red balls. The number of green balls are 3, the number of blue balls are 2 and the number of red balls are 4 in a random sample of 5 balls. Okay, so let us have or choose this one. If a random selection from it has been taken and we have selected 5 balls randomly from them, okay, and the total number of balls here we have 3 plus 2 plus 4, these are 9. Okay, adding them and we will get 9, and this is what this is, and from it we have chosen 5 balls. Find the probability that both blue balls and at least one red balls are selected. Okay, so now solving it, this is the solution. We can very easily see that the total number of selected ball will be 5, and if all the 2 balls are selected, okay, 5 minus 2, so the remaining balls are 3 in number. Okay, so we know that all of these 2 balls are the blue one, and out of the 2 blue balls we have selected the 2 ones, so it will be 2 choose 2, so it would be 2 factorial divided by 2 factorial, 2 minus 2 factorial, this is 0 factorial, this is also 1, so it will be 1. Now in the remaining 3 balls, all items will be green and red, and the statement given here is that at least one red ball should be here. Okay, there shouldn't be any combination in which we don't have any red ball. So therefore the number of combinations for this 3 we can have are, this is red, this is green. For the first combination we can have 1 red ball and 2 green balls, and adding them we can have this 3. Okay, 1 plus 2. Similarly, we can have 2 red balls and 1 green ball. The conditions are satisfied, and we can see that adding them together we can get 3, and the last one here can be 3 and 0. Adding them together we can get 3, and also the red balls are available. We cannot here have 0 3, because writing 0 3 here we will violate this condition and it is not admissible. Okay, so we cannot use this condition, so therefore we are removing it. So therefore these are the conditions. So let me write these conditions here. These are the conditions, and for them we will have here either this situation, and for it we will have the red ones. So the total number of red balls are 4. Okay, and the other ball is green, so the total number of green balls are 3. Okay, from 4 we have to select 1 red ball, and from the 3 we have to select 2 green balls as it is given here, and dividing it over what? Dividing it over the total number of combinations, which are from the total of 9 balls we have to select 5 balls. Okay, we already know that the 2 balls are the blue one, which is the mandatory condition. So 9 choose 5. Okay, so this is what we have, and let me indicate that which combination is it. This one is this one. Okay, or we can have another condition, and that condition is here, this one. Okay, let me write it here, and here writing it we can see that the total number of red balls are 4 again, the total number of green balls are 3, and in this condition we have selected 2 red balls and 1 green ball, and this is what we have, and dividing it over the total number of the combinations, which are 9 choose 5. Okay, so this is what we have. Okay, now let me
move it to the other side. Okay, this one. And the third combination here is, let me use this color, this one is here. Okay, let me write it here. So this condition can also occur, and this is again or, plus means or, and also here the total number of red balls are 4, the total number of green balls are 3. Okay, from 4 we have to select 3. Okay, and from the 3 green balls we have to select none of them, and dividing it over 9, choose 5. Okay, again writing them, we will get what this would be. 9 choose 5 is the LCM, and here we will have 4 choose 1, 3 choose 2, or 4 choose 2, 3 choose 1, or 4 choose 3, 3 choose 0. Okay, so these are what we have here. Now solving it, what we will get, the answer of it will be 17 divided by 63, and that is what we have got after solving this one. Okay, so that's it for today, in which we have seen the solution of question 5.44. If you guys have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.46, and the statement of it is: a large company has an inspection system for the batches of small compressors purchased from vendors. A batch typically contains 15 compressors. In the inspection system, a random sample of 5 is selected and all are tested. Suppose there are 2 faulty compressors in the batch of 15. Okay, so let me first write the given data here. Okay, so the total number of compressors which are here are 15, and from them 5 will be selected, means the sample number of the compressors are 5. Okay, out of these 15, it is known that 2 are faulty. Let me write F for faulty, 2 are faulty. Okay, on the basis of it, let me write the options for it. In part A, what is the probability that for a given sample there will be 1 faulty compressors? Okay, it means that if 5 are selected, what is the probability that out of those 5, 1 will be the faulty compressor? And in part B, what is the probability that inspection will discover both faulty compressors? Mean in all those 5 samples there will be all 2 faulty samples in it. Okay, so again this is a question of the hypergeometric probability distribution. So let me solve it here. In solving part A of my question, what we have to do here, first of all, write the total number of samples. So out of 15 there will be 5 selected. Okay, in these 15 and all the faulty samples in first sample, in part A, what we will have, we must have 1 faulty compressor which will be from these 2 faulty ones. So 2 choose 1. Okay, so the remaining non-faulty will be 13, and therefore the other 4 will be non-faulty as well. You can see here that adding them you will get this, and adding them you will get this one. Okay, so this is what you have to do. Okay, so this is doing it. And what is this? Let me write the formulation for it. It will be H1 from 15 5. Okay, and this is what we want to find out, and here we will have the value of k. So now here finding it, what will we get? It will be 2 factorial divided by 1 factorial. 2 minus 1 is 1 factorial multiplied by 13 factorial divided by the 4 factorial multiplied by 13 minus 4 is 9 factorial whole divided by this 15 factorial divided by 5 factorial multiplied by 15 minus 5 is 10 factorial. So finding it out, the answer of it will be 0.476, and that is what, that is basically the solution of part A of my question. Okay, now solving part B of my question, what we will have to do here, we have to replace them with 2. So what will I get here? The total number of samples will be here the similar one, so it will be 15, choose 5. Okay, and here now as the both faulty compressors will be selected, so therefore it will be 2, choose 2. Okay, and from the remaining non-faulty we will have 3. Okay, so we will get this one, and solving it, when we will solve it, the answer of it will be 0.095, and this is what, this is basically the solution of part B of my question. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.47, and the statement of this question is: a government task force suspects that some manufacturing companies are in violation of federal pollution regulations with regard to dumping a certain type of product. 20 firms are under suspicion. Okay, so let me take this 20 number, but not all can be inspected. Suppose that 3 of the firms are in violation. Okay, so in given data, let me write here the capital N equal to 20, and the suspected number of firms which are out of these 20 are basically 3 are suspected. Let me represent it with this. What is the probability that inspection of 5 firms will find no violations? And B, what is the probability that the plan above will find 2 violations? Okay, so let me solve them here one by one and solving part A of my question, and we can very clearly see that all of these parts are basically related to the hypergeometric probability distribution. So let me first find that out of the 5 firms we will find no violation, mean no suspected firm will be selected, so therefore N is 5, and I want to find out what, let me write here the total combinations which are from 20. We have to select 5 firms. Okay, in these 5 firms we have selected no suspected firms, so out of these 20, 3 were suspected, so 3 were suspected, and out of these 3 we will find none. Okay, the remaining ones will be 17, and from the 17 what will we get? We will get all the 5 firms. Okay, so this is what we have here. We can again very clearly see that 0 plus 5 is this 5. Okay, and also 3 plus 17 is 20. Okay, these should be here consistent, so writing them here we will find what the answer of it will be 0.399. okay, and that is what, that is basically the solution of part A of my question. In part B, it is asking that what is the probability that the plan above will find 2 violations, means out of these 3 we will have 2 violations, so therefore we will have here what, we will have again the similar number of selections which are from 20 we have to select 5, and out of 3 we will have now 2 violations. Okay, therefore the remaining total firms are 17, while the remaining ones here would be 3 because 2 are here and 3 are here. So finding them out, what we will get, let me solve them here as well for your convenience. It will be what? It will be the 3 factorial divided by 2 factorial, and 3 minus 2 is 1 factorial, multiplied by 17 factorial divided by 3 factorial. 17 minus 3 is 14 factorial whole divided by the 20 factorial divided by 5 factorial multiplied by 20 minus 5 is 15 factorial. Okay, finding it answer. Similar operation has been done here as well. So finding the answer of it, what we will get 0.132, and that is what, that is basically the solution of part B of my question. Okay, so that's it for today, in which we have solved question 5.47 of the exercise. Okay, if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.48 and the statement of it is: every hour 10,000 cans of soda are filled by a machine, among which 300 underfilled cans are produced. Okay, so these are the total number of cans, among which 300 underfilled cans are produced. Each hour a sample of 30 cans is randomly selected and the number of ounces of soda per can is checked. Denote by X the number of cans selected that are underfilled. We have to find the probability that at least one underfilled can will be among those sampled. Okay, so first of all, let me write the given data here. In given data, the total number of cans here are 10,000. Okay, and 30 are underfilled. Let me represent them with U, and these are 300. Sorry, 300 are underfilled. So now in order to find here the probability of the underfilled, because n here is very huge, so therefore in order to find the probability of the underfilled, we have to write the total number of underfilled dividing it over 10,000. Okay, so it will be what? It will be 0.03. Okay, now each hour a sample of 30 candidates randomly selected, so therefore n is what? N is 30, and we have here X, the number of cans selected that are underfilled. Okay, these are the underfilled cans. So so what do we have to find out here? Let me write here the required data. So we want to find out the probability that X is greater or equal to 1. We have to find it out. Okay, so in order to find it out, we can also write it this P of X greater or equal to 1. This is also equal to 1 minus probability that X is less than 1. Okay, so less than 1 is what? This less than 1 is basically equal to 0. Okay, so we have to find it out. So okay, so this is the required thing we have to find here in this question. Okay, so now solving it, we can very clearly see that it is the binomial probability problem, where the probability is given, the number of items selected are given. Okay, and the items which has to be selected are also given, which is here as well. Okay, so we have to find here the probability that X is greater or equal to 1. This is 1 minus probability of X equal to 0. So this can be written as n choose 0. Okay, and then probability raised to power 0, 1 minus p raised to power n minus 0. Okay, let me write these values. So it would be 1 minus n choose 0 is n is 30, and choose 0, p is 0.03. Okay, and this is 1 minus 0.03, n minus 0 is 30. Okay, let me write it out. It would be 1 minus, this is what? Let me simplify them. This is equal to 1. This is also equal to 1. Okay, and this remaining term will be what? It would be 0.97 raised to the power 30. Okay, now calculating it and then writing the answer. The answer of it would be 0.599, and that is what? That is basically the solution of question 5.48, which is related to the binomial approximation. Okay, we have approximated the hypergeometric probability to the binomial approximated probability. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 5.49, and the statement of this question is: the probability that a person living in a certain city owns a dog is estimated to be 0.3. Okay, so the probability given here is 0.3. Find the probability that the 10th person, okay, the 10th person randomly interviewed in that city is the 5th one to own a dog. Okay, so what is given here? Let me write here. This is the given data. In given data, we have to write that the probability that a person owns a dog is 0.3. Okay, and also we have to find the probability that the 10th person randomly interviewed in that city is the 5th one to own a dog. Okay, so 10th person who is interviewed is actually the 5th person who owns a dog. Okay, we have to find the probability of it. Okay, so let me write here this probability as well, and this is it. So now in solving this question, what do we have to do? Let me draw the diagram for it. So diagrammatically we can write it like, suppose we have these 10 slots. Okay, we have these slots 1 2 3 up to this 10th slot, 1 2 3 up to this 10th slot. Okay, so here in order to write that whether a person has a dog or not, yes, Y is for a person owns a dog, and N for person doesn't own a dog. Okay, so therefore writing it here, this 10th person will be the 5th one who owns the dog, so it will be Y5. Okay, also all previously here we will have all the 4 Y's. Okay, so those would be, let me write here, Y1, Y2, Y3, Y4, anyone, and 5th one will be here. All others will be the person who doesn't own the dogs, so those would be N1, N2, N3, N4, and 5. Okay, so 5% here will be the people who doesn't own the dog, while the 4 ones here will be the person who owns the dog. Okay, so therefore this will be what? This will be the probability here, and here in order to write them here, what would we get for this combination here? We would get here the total number of people who owns the dog would be 0.3, which is the probability that a person owns a dog. 0.3 multiplied by 0.3 multiplied by 0.3 multiplied by 0.3 and multiplied by 0.3. Why is it? Because this is Y1, Y2, Y3, Y4 and Y5, and multiplying them all together, we will get what? We will get the probability that a person, all the persons that who owns the dog, this is the probability for them, and also for them as well we have to multiply their probability as well, and it would be 1 minus 0.3, so 0.7, 0.7, 0.7 multiplied by 0.7 and 0.7 as well. These are all multiplied with them as well, so it is N1, N2, N3, N4 and 5. So here we will get what? It would be, the answer of it would be 0.3 raised to the power 5 and 0.7 raised to the power 5. This is for what? This is for this specific combination. Okay, but keep it in your mind that there is a possibility that here we can have N1, here we will have Y1, and here we will have Y2, and so on. There can be many combinations for these 9 items. Okay, and each 9 item will give us this probability. Okay, you know that there are n there are 9 items, and out of those 9 we can have here 4. Yes, so this is what, this is clearly the combinatorial problem, where this one is true for only a specific combination, while to find the total number of combinations, what do we have to do? We have to find the 9 choose these 4. Okay, these 4 are the yes, so we have to multiply them with this probability, just like we have done in the binomial probability. Therefore, this one is called the negative binomial probability. Okay, so now writing it here, what will we get? Here we have the total number of items equal to 9 before it, and out of 9 we have the combinations of these 4. Okay, so this one here, and also multiplying them with 0.3 raised to power 5 and 0.7 raised to the power 5 as well. Okay, so finding it here, we will get 9 factorial divided by this 4 factorial, and 9 minus 4 is 5 factorial. Writing it here as well, so 0.3 raised to power 5 and 0.7 raised to the power 5 as well. Okay, now multiplying them and then finding the answer of it, we will get 0.0515, and that is what, that is basically the solution of our question 5.49. Okay, so that's it for today, in which we have discussed the negative binomial probability. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.50, and the statement of this question is find the probability that a person flipping a coin gets A, the third head on the 7th flip, B, the first head on the 4th flip. Okay, so in this question we will not only solve this question, but we will also try to understand the difference between the negative binomial probability and geometric distribution as well. So this is what the first part is related to the negative binomial distribution. Okay, while this part B of this question is, this is related to the geometric distribution or geometric probability distribution. Okay, so let us solve them. So first of all, let me solve part A of my question. In part A, the third head on the 7th flip means the coin has been flipping and the person has flipped it 7 times, and on the 7th flip he has got third head. Okay, so therefore let me again illustrate it with the help of this diagram. So it has 1, 2, 3, 4, 5, 6 and 7 slots. Okay, and in this slot, this is the 7th slot here, this is the 7th slot here, and here we have got our third head. Okay, so let me call it H3. Okay, so H1 and H2 will be somehow here. So we have H1, H2 here in all these 6. Let me represent them with this. So these are the remaining 6 slots. In these 6 slots, we will have 2 heads and also T1, T2, T3 and T4 tails. Okay, so here what would we get in order to get the 3 heads and 4 tails? The answer we will get here would be 0.5 raised to the power 3 for these 3 heads, because of H1 multiplied by H2 multiplied by H3. Okay, their probabilities. Okay, let me represent them with P of H1, P of H2, P of H3. So multiplying them, we will get here 0.5, and also for the tails, we will have here P of T1, T2, T3 and T4. So we would get here 0.5 raised to the power 4. Okay. More concisely, here we can write it like P of H1 multiplied by P of H2 multiplied by P of H3. Okay. So it will be what? It will be here. It will be here because 0.5, 0.5, 0.5, and also here for this one P of T1, P of T2, P of T3 and P of T4. Okay, these would be here, and taking them now, multiplying them together, and here we will get this one. Okay, so this is for this specific combination here. Now in order to find different combinations for H1, H2, T1, T2, T3 and T4, because this third will remain here. So therefore, in order to write it here for all of them, we will have the total number of items here are 1, 2, 3, 4, 5, 6. Okay, so out of 6, we have to take the combinations with which this H1 and H2 makes with them. So it is 6, choose 2. Okay, so let me solve them. So it would be 6 factorial divided by the 4 factorial multiplied by 2 factorial, and it would be 0.5 raised to the power 7. Okay, so ultimately the answer of it would be 0.117. Okay, and that is what? That is basically the solution of part A of my question. Okay, so all of this is related to the negative binomial distribution, because this is the formula for the negative binomial distribution which we have seen now. Now in order to discuss part B of my question, the first hat on the fourth flip. Okay, so therefore let me move down somehow. Okay, so here what we can do, the first hat on the fourth flip means we will have here 4 slots. Okay, and in this 4 slot we will get what? Here we will get the first head, while all the others will be tails. T2, T3 means these are basically the successions until and unless we get these heads, which is basically the success. So the number of trials or number of flips until and unless we will get heads or the success is basically represents the geometric probability distribution, and the probability of it would be what? It would be, this is probability of T1 multiplied by the probability of T2 multiplied by the probability of T3. Okay, so these are basically the failures or the tails, and the success we call to the head. This is here P of H1. So therefore it would be 0.5 multiplied by 0.5 multiplied by 0.5. This would be 0.5 raised to the power 3, and multiplying it with the probability of H1, and let me call it 0.5 as well, and it is what? It is basically 0.5 raised to the power 4, and this is what? This is basically the solution of question 5.50 part B. Okay, so in this question or in this part we have discussed what? We have discussed the geometric probability distribution, which is basically the goal of my question, in which I have to discuss the difference between binomial probability and geometric probability distribution. So that's it for today, in which we have discussed that negative binomial distribution basically we get when the number of successes are available in all the trials, but we have certain number of successes and we want to identify that a certain number of success has been occurred at some trial, while in the geometric probability distribution we will do the trials and unless and until we will get the success or the required outcome. So that's it for today. If you have any question, you can ask me in comment box. See you soon.
Welcome back, guys. This is question 5.51, And the statement of this question is 3 people toss a fair coin and the odd one pays for coffee. If the coins all turn up the same, they are tossed again. Find the probability that fewer than 4 tosses are needed. Okay, so this is the statement. Now first of all, let me write the given data. Okay, so what are the conditions which are given here? So there are 3 people who are tossing a fair coin. If the coins all turn up the same, they are tossed again. Okay, what does it mean? The 3 people are tossing a coin and the odd one of them, okay, if one is tail, 2 are heads, then this tail will pay for the coffee. Similarly, if one is head and the other 2 are tail, this heads one will pay for the coffee. Okay, so this is what we have. Similarly, there can also be the option that all the 3 outcomes can be the similar one. I mean, it can be tail, 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 or it can be heads, heads. Okay, so in mathematics you know that how to write this or can be written as plus. Okay, and to write the probability that all are same, we have to write the probability of tail multiplied by the probability of tail multiplied by the probability of tail plus probability of heads, the probability of heads multiplied by the probability of heads. Okay, what does it mean? This is basically the probability that we are getting the similar outcomes. Okay, so here putting the values 1 by 2 multiplied by 1 by 2 multiplied by 1 by 2 plus 1 by 2 multiplied by 1 by 2 multiplied by 1 by 2, because these are independent of each other, or it can be 1 by 8 plus 1 by 8. So ultimately it will give me 1 by 4, which is the probability of similar outcomes. Okay, that is what we have. Similarly, the probability of the different outcomes in which one is the different, this can be found out by 1 minus probability of similar. Okay, so it will be 1 minus 1 by 4, which is 3 by 4. Okay, so that is what, that is basically the probability that we will get the different number of items here. Okay, which can be either this or this, in which the odd number of the item will be present here. Okay, so now in order to find the probability that fewer than 4 tosses are needed, one we can write, let me write here the solution. Here the probability that x is less than 4, it can be what? It can be written as either in the first toss we will get these total number of items, which are what? Which are basically the different one. Okay, so this can be the first trial in which we can get this 3 by 4 probability, or it can be the second one, means in the first trial we will get this similar and the second one we will get 3 by 4. So this would be 1 by 4 multiplied by 3 by 4, or okay, so this was the first trial, this is the second trial. In the third trial we can also get what? There is also a possibility that in the first 2 trials we will get the similar ones, which are 1 by 4 multiplied by 1 by 4, and the last one we will get 3 by 4. Okay, this is also a probability. So these situations can also occur here. Now writing them here, it will be 3 by 4 plus 3 by 16 plus 3 by 64. Okay, so now this is what we have. Adding them all together, what we will get, the answer of it would be 63 by 64, and that is what? That is basically the solution of my question 5.4. 5.1. Okay, so that is basically the solution of my question, in which I have basically used what? I have used the geometric probability theorem. This is for the condition where we will get the success in the first trial. This is what we will get the success in the second trial, while this is what we will get success in the third trial. Okay, so that's what we have done for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.52, and the statement of this question is: a scientist inoculates mice one at a time with a disease germ until he finds two, okay, so let me underline it, that have contracted the disease. If the probability of contracting the disease is 1 by 6, what is the probability that 8 mice are required? Okay, so now in solving it, let me solve it here. Okay, first of all, let me illustrate it by using this diagram. Okay, so let me have here this slot in which I have 8 slots. Okay, so here this will be done until and unless he will have here the 2 mice. Okay, so here let me write here, this one is the first, second, third, fourth, fifth, unless and until here we have the 8th one, and here we have to find its probability. 8 mice are required, and here if 8 mice are required, the last one here would be what? This will be the second mice. Okay, one will be here somehow, so here this one will be the second one, or another one will be here. So here we will have 2 mice which have contracted the diseases. Okay, so therefore the probability that 2 mice has contracted the disease while the 2 has not, so this is the probability of the contracting the disease is what? This is 1 by 6, and the probability of not contracting the disease, this is 1 minus P of D, that is 5 by 6, because this is 1 by 6. Okay, so here as 2 mice are here which has the disease, while the remaining 6 mice will not have the disease, so therefore the answer of it would be what? It would be 1 by 6 raised to the power 2 and 5 by 6 raised to the power 6. Okay, so this is for the only one combination which we will have here, but here we can see that here we have, this is 6, this is 7. Okay, here we have what? Here we have these 7 slots. In these 7 slots we can have 1 mice which has contracted the disease anywhere here, so therefore out of them which we have 7 slot, we can have only one which can get here. Okay, so writing it here, what I can write here, it would be 7 factorial divided by 6 factorial into 1 factorial multiplied by 1 by 6 raised to power 2 and 5 by 6 raised to power 6. Okay, so here we will have 7 multiplied by 1 by 6 raised to power 2 and 5 by 6 raised to power 6. Okay, calculating it, the answer of it would be 0.0561, and that is what? That is basically the solution of my question 5.52. Okay, so you have seen that what is this? This is basically the negative binomial probability. Okay, and we have solved it by using this formula which we have got from this one. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.53, and the statement of this question is: an inventory study determines that on average demand for a particular item at a warehouse are made 5 times per day. what is the probability that on a given day this item is requested, part A, more than 5 times and part B not at all. Okay, so this is basically the problem which is related to what? Which is related to the Poisson distribution. Okay, add the formula for calculating the number of times an item is requested which are greater or lower than the average number of times will be the probability that x is equal to k, where k are the number of times an item is requested or done. It would be what? It would be the lambda k, okay, exponential of minus lambda divided by the k factorial, where k is what? K are basically the number of items and lambda is the average amount. Okay, so this is what we are going to do today. Okay, so in part A of my question, we can see that very easily we have to find the probability that the items are what? Items are more than 5 times. So we have to find this one, and it can be calculated by 1 minus the probability that the items are less than or equal to 5. Okay, we have to keep in our mind that the average number of times an item has been ordered is what? That is also 5, which is given here. Okay, in order to find it out, we know that the probability that x is less than or equal to 5, this can be calculated by summing the Poisson distribution from k equal to 0 up to 5. Okay, and it would be what? It would be the lambda k exponential of minus lambda divided by the k factorial. Putting values here, what I will get here, k equal to 0 up to 5, lambda is 5 here, so 5 raised to power k and exponential of minus 5 whole divided by the k factorial, or taking it out, this is a constant, exponential of minus 5, and the other items here would be from k equal to 0 up to 5, 5k divided by the k factorial. Okay, let me write them down. It would be what? It would be the exponential of minus 5, and it would be 50 divided by 0 factorial plus 51 divided by 1 factorial, because k is ranging from 0 to 5. Also 5 square divided by 2 factorial plus 5 cube divided by 3 factorial plus 5 raised to power 4 divided by 4 factorial plus 5 raised to power 5 divided by 5 factorial. Okay, so finding it out, and then let me move down somehow. What we will get after calculating it out, 0.616. Okay, so this is what? This is for the probability that x is less than or equal to 1. Okay, so now we have to find out the probability that x is greater than 5. So therefore we have to subtract it from 1, because this is the thing which we want to find out. So let me point it out here. Okay, this is what we wanted to find out. So therefore the probability that x is greater than 5 would be what? It would be the 1 minus the value of probability x is less than or equal to 5. This is 0.616. Let me put it here. Okay, so now subtracting it from 1, what I will get, the answer of it would be 0.384. Okay, so that is what? That is basically the solution for part A of my question. In solving part B of my question, what do you have to do? You have to put the value of k equal to 0, because this is for not at all, and here it will be for k equal to 0. Putting k value equal to 0 here, the answer of it you will get will be the answer of part B of my question. Okay, so that's it for today, in which we have seen the introduction to the Poisson distribution. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.54, and the statement of this question is, according to a study published by a group of University of Massachusetts sociologists, about two-thirds, okay, let me underline it, two-thirds of the 20 million persons in this country who take Valium are women. Assuming this figure to be a valid estimate, find the probability that on a given day the fifth prescription written by a doctor for Valium is A, the first prescribing Valium for a woman, and B, the third prescribing Valium for a woman. Okay, so in this question, what do we have to do? We have to use our developed concepts regarding the probability distribution to see that which probability distribution will be valid here. Okay, so in part A of this question, we can very clearly see that the fifth one will be the first one. Okay, so this can be translated like that the events have been done unless and until we have got the success. Okay, so this is part A. Let me write here. Okay, so solving part A of my question, we can very clearly see that this is what. Let me represent it by using this diagram, okay, in which we have 5 slots. Okay, and here this is the fifth one, and this fifth one is what? This is the first prescribing Valium for a woman. Okay, so means this is the first for this one, while all the others were not for the woman. So therefore the probability of it was what? The probability of it was 2/3. Okay, means this was 2/3, and all others were 1/3, 1/3, 1/3, and 1/3. Okay, so in finding the total probability of these independent events, we have to multiply them together, and ultimately we will get 1/3 raised to the power 4, 2/3 multiplying with it. Okay, so this is what? This is basically the representation related to the geometric probability. Okay, so the part first of A is related to the geometric probability. In part B, the third prescribing Valium for a woman. Okay, so it means that this is not the first one, while the third one is fixed, which is the fifth one. So that's why here we have to use what? Here we have to use the negative binomial distribution. Okay, so you have to keep in your mind that in geometric probability distribution, the last one is the first one, which is the success, while in the negative binomial distribution, there is not a fixed last one, which is the first one, while it can be any fixed number of the trial which has been done over this last trial. Okay, so let me again use the same representation for it. Okay, so there are 5 slots. Okay, this is the fifth one. This is 4, 3, 2, 1. Okay, this fifth one is what? This is basically the third prescribing Valium. Okay, means this is what? This is 2/3 probability. Okay, while these 4, out of them there can be 2 prescribing women, and the 2 non-women here would be here as well. Okay, so therefore what we can do here, these 2 can be anywhere here. So this is the combinatorial problem. So therefore we have to take all these 4, and out of these 4 we have to make the arrangements for the 2 prescribing Valium. Okay, the probability for the prescribing Valium are 2/3 raised to power 2. Okay, because 2 item will appear here, and the non-prescribing non-women item here will be 1/3, and those would also be 1/3, and here this 2/3, which is for this fifth item, will also be here. Okay, so writing it again here, it would be 4 choose 2. Okay, and this 2/3 multiplied by this 2/3, it would be 2/3 raised to the power 3 and 1/3. So this is what? this is the solution for part B of my question, which is related to the negative binomial distribution. Okay, so that's it for today, in which we have seen the relationship between the geometric probability and negative binomial distribution. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.55, and the statement of this question is: the probability that a student pilot passes the written test for a pilot's license is 0.7. Find the probability that a given student will pass the test on the first try and before the fourth try. Okay, so let me first write the given data here, that the probability that he will pass a test is 0.7, and he doesn't pass the test, let me call it Q, and that Q is 1 minus 0.7, that is 0.3. Okay, so this is the given data. In part A of this question, let me solve it. So solving it, in part A of my question, I am asked that on the third try he will pass the test. So this is what, this is basically the geometric probability distribution in which a person will try and will solve or will pass the test on the third try. Okay, what does it mean? That, let me draw here this hypothetical diagram. Okay, there is first try, second try, and then third try. Here he will not pass it, so therefore here it will be Q, and here it will be P. Okay, so therefore now let me write their probabilities. So the probability which is Q here is 0.3, here it is 0.3, and here it is 0.7. So therefore the answer of part A is what? That is 0.3 multiplied by 0.3 multiplied by 0.7. So that is 0.3 whole square multiplied by 0.7, which is what? Which is 0.0630, and that is what? That is basically the solution of part A of my question. Okay, in part B we are asked that a person will pass the test before the fourth try. Okay, what does it mean? That he has to pass the test before the fourth try, means before fourth try. What does it mean? It means that he has to pass it on or before the third try. Okay, so he has two tries are less than or equal to 3. What does it mean? That he has to try and pass them less than or equal to 3. What does it mean? That the try is first, or the try is second, or try is third. He will either pass it on the first try, on the second try, or on the third try. Okay, so let me write their probabilities, and each term here is basically what? Each term here is basically the geometric probability where the terms here will be given. So therefore let me write their probabilities. So on the first try he will pass it, the probability of passing over the first try, I have to write it here, or the probability of passing it over the second try, and the probability of passing it over the third try. I have to write their probabilities. So in order to write the probability of it, the first try and he has passed it, the probability of it is 0.7. Okay, in the second try means he has failed it on the first try, so therefore it will be 0.3, which is the first try he has failed it, and then on the second try he has passed it, so therefore this is 0.7. In the third try means he has failed it on the first two tries and passed it over the third try, which is what? Which is the given one here as it is in part A. So therefore it would be 0.3 whole square multiplied by 0.7. Okay, so these are what? These are the individual geometric probabilities for each of the terms which are here. Okay, so now calculating it and then adding them all, the answer of it would be 0.97 0.30, and that is what, that is basically the solution for part B of my question. Okay, so that's it for today, in which we have seen the solution of question 5.55, which is related to the geometric probability distribution. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.56 and 5.57, which are closely relevant with each other, and today we are going to discuss the probability distribution, which we are going to follow and solve the questions like this one. So in question 5.56, the statement is, on average 3 traffic accidents, okay, 3 traffic accidents per month occur at a certain intersection. What is the probability that in any given month at this intersection, A, exactly 5 accidents will occur, B, fewer than 3 accidents will occur, and C, at least 2 accidents will occur? Similarly, in 5.57, we are also given some average number of errors in the textbook, and all of these questions where the average number of traffic accidents, average number of errors, average number of items are given, and we have to find the exact number of accidents or exact number of errors, or some maximum or minimum limit of accidents or errors are given. So there, what would you do? You will have to use the probability distribution, which is very famous, and that is basically the Poisson probability distribution. And the formula we are going to use for it is probability that x equal to k, that is equal to the exponential of minus lambda and lambda raised to power k divided by the k factorial, where lambda is what? Lambda is the only factor here, which is the average value. Okay, so in each question here, average values are given. This is 3 and here we have 2. Okay, so in order to find them out, let me first solve question 5.56, and in solving it, let me use this black color. Now let me solve question 5.56, and in solving it, this is the solution. And let me first write the given data, where the given lambda or the average value is 3 accidents per month. Okay, so this is lambda. In part A of it, what do we have to find out? Exactly 5 accidents will occur. So if suppose x is the number of the accidents, we need to find out the probability that x is 5. In B, fewer than 3 accidents will occur. Probability that x or the number of accidents are less than 3, which is here. And in C, at least 2 accidents will occur, means probability of x is greater or equal to 2. Okay, so here we have to find it out, and previously I have told you guys that the formula for the Poisson distribution here would be what? That would be probability of x equal to k, that is equal to the exponential of minus lambda k divided by the k factorial, which is written here. So now, as this lambda is given, so it is clearly the Poisson probability distribution problem. So therefore, let me write here this px equal to 5. So for it, k is equal to 5, so therefore it would be the exponential of minus 3, and lambda, which is 3 as given here, this is 3, the value of k is 5 here. Okay, so this is 5 divided by the 5 factorial. Okay, so what would we get? Exponential of minus 3, this 3 raised to power 5 is 243. Okay, multiplying it with it, and 5 factorial is 120. Okay, so finding the value of exponential of minus 3, what would we get? 0.0498 multiplied by 243 divided by 120. Okay, and then finding the answer of it, the solution would be 0.1008, and that is what? That is basically the solution for part A of my question. Okay, in part B, which is basically this one. Let me solve it here. Okay, this is the probability that x is less than 3. This is what? This is basically the probability that x is less than or equal to 2, or we can very easily write it all the values of x is less than or equal to 2. Those would be the probability that x is equal to 0, the probability that x is equal to 1, and the probability that x is equal to 2. Okay, so these are all what? These are all the Poisson probability formulas, where in each of them I have to use the formula which we have here. Okay, for all of them the values of k are 0, 1, 2. So let me write their values. So in this formula, putting these values, it would be exponential of -3, because the value of the lambda will remain the same. Okay, multiplied by the 3 raised to power 0 divided by the 0 factorial plus exponential of -3 into 3 raised to power 1 divided by 1 factorial plus exponential of -3 multiplied by 3 raised to power 2 divided by 2 factorial. Okay, so finding it out, because the value of exponential -3 is already known, and then finding the other values, the answer of it would be what? The answer of it would be 0.423. Okay, so this is the solution for part B of my question. In order to proceed to part C of my question, let me move down somehow. Okay, so part C of this question is probability of x is greater or equal to 2. We can very easily find it out by 1 minus probability of x is less than 2. Okay, so it would be what? It would be 1 minus the probability of x equal to 0 plus the probability that x is equal to 1. These are the values which are less than 2. So again, these are for the Poisson distribution. Let me write them here. 1 minus probability of x equal to 0, it would be x exponential of -3 raised to power 0 divided by the 0 factorial plus exponential of -3 raised to power 1 divided by 1 factorial for the values of k equal to 0 and 1. Okay, and then adding them, subtracting it from 1, what would I get? It would be 1 minus exponential of -3 multiplied by 4. So ultimately the answer of it would be 0.8009. Okay. So that is what? That is basically the solution for part C of my question. Okay, so this is basically the solution for question 5.56. Now let us proceed to question 5.57. On average, a textbook author makes 2 word processing errors per page on the first draft of her textbook. What is the probability that on the next page she will make 4 or more errors and B, no errors? Okay, so in this question again the average value is given, which is 2. Okay, and the formula is already given. Let me move down somehow for this one as well, and let me use this blue color for it. So this is question 5.57, and in part A of my question I have to find probability that 4 or more errors are here. So if I represent the number of errors with x, so x are greater or equal to 4, so it would be 1 minus probability that x is less than 4. Okay, let me write them here. So it would be all the values of x would be probability of x is 0 plus the probability that x is equal to 1, the probability that x is equal to 2, and the probability that x is equal to 3. Okay, the value of lambda is already given, which is what? Which is 2. So this is here as well. Okay, let me use the same formula which I have used for it, which is here, which is exponential of minus lambda raised to power k divided by k factorial. Okay, so let me write them here. It would be 1 minus exponential of -2 raised to power 0 divided by 0 factorial plus exponential of minus 2 2 raised to power 1 divided by 1 factorial plus exponential of minus 2 2 raised to power 2 divided by the 2 factorial plus exponential of minus 2 2 raised to power 3 divided by the 3 factorial. Okay, so then solving it and finding the answer of it, the answer of it would be 0.1441. Okay, and that is what, that is basically the solution for part A of my question. In moving to part B of my question, I have to find the probability that we will get no errors. So this is what I want to find out, the probability that the number of errors are 0. Okay, this is x equal to 0, or this is the same one as it is here. So therefore writing it exponential of minus 2 2 raised to power 0 divided by 0 factorial, which is same as exponential of minus 2. So the answer of it would be 0.135, and that is what, that is basically the solution for part B of my question. Okay, so that's it for today, in which we have seen the solution of question 5.56 and 5.57 by using the Poisson distribution, okay, which is the formula which we have written here. So I hope this is now understandable, and if you guys have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.58, and the statement of this question is: a certain area of the eastern United States is on average hit by 6 hurricanes a year. Find the probability that again in a given year that area will be hit by A, fewer than 4 hurricanes, B, anywhere from 6 to 8 hurricanes. Okay, so this is one of the problem which is related to the Poisson probability distribution. What we can do here is that we can solve it by two methods. One is by using the formulas which I am going to write here. Okay, so the formula here is the probability that x equal to k equal to exponential of minus lambda k divided by the k factorial, where lambda is the average value given here already, and here lambda is 6. Okay, so in order to find the fewer than 4 hurricanes here, what we can do, we have to find the probability that x is less than 4, which is the probability that x is less than or equal to 3. What we can do here is that we have to find the probability of x equal to 0 plus x equal to 1 up to also probability that x equal to 2 and plus probability of x equal to 3. These are all the values of k. Writing them here, lambda will remain the same. You have to add them and then you will find the probability of it. Okay, this is basically one method. The other method is the use of the Poisson distribution table. Okay, so here we have a table, and in that table what we can do here is that we have this value which is k, and also the value of lambda which is given. These are the two factors here we have, and these are the two parameters which are going to be the searchable parameters in the table. Okay, let me go to the table now. This is the probability that x is less than or equal to 3. Let me go to the table. So this is the table, you can see it here. Okay, so let me increase it. Okay, you can see here that this is a table, and these are all the values for the lambda 0.1 up to 1.8, and all the values of it are basically what? These are the values of the lambda, while these are the values of x or k. Okay, these are the values. So we have to do it for what? Our value of lambda is here 6. Okay, so we have to search for 6, and in the column of the x we have to search for 3. Okay, so there we will find that this is the formula, and here you will have to do it. Okay, this is basically lambda. Okay, not -1. Okay, so now let me search for 6. Okay, so this is 6, this is for lambda. okay, what we have here, and for the value of x we have here 3. Okay, so here it will be the value, because we have to find out the probability that x is less than or equal to 3, and for that we had here 6, and so therefore the answer of it is 0.1512. okay, and that is basically the solution of part A of my question. 0.1512. Okay, so that is basically the solution of part A of my question. In part B, we have to find the probability that it is anywhere between 6 to 8, means it is greater or equal to 6 and less than or equal to 8. Okay, so therefore let me move to the same page in the table. Okay, so this is the similar one, and here we have to find out what we have to find, that x is greater or equal to 6 and less than or equal to 8. Okay, so here what would happen, we have to subtract the value of x is less than or equal to 8. From it we have to subtract what? We have to subtract the value of x which is less than or equal to 5, because 6 should remain in between them. Okay, so it should be here. Why? Because if this is the table and here we have here the 8th one and we keep it here the 5th one, so all the values will remain here, would be from 6 to 8, and therefore we have to keep them here as well. Okay, so now let me find out the value of lambda will remain the same, which is 6, and the value of x is less than or equal to 8. Here it is this one, this would be 0.8472, 0.8472 minus probability of x is less than or equal to 5. This is 0.4457. Okay, so when you will subtract it from it, it will be around 0.40, which is what? Which is basically the solution or answer of part B of my question. Okay, so this is what. Let me move to the main page. So the answer of part B is 0.40. Okay, so that's it for today, in which we have solved question 5.58 and seen that how to use the Poisson distribution table in finding the probabilities whatever we have. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.59, and the statement of this question is: suppose the probability that any given person will believe a tale about the transgressions of a famous actress is 0.8. What is the probability that part A of it is the sixth person to hear this tale is the fourth one to believe it, and B, the third person to hear this tale is the first one to believe it. Okay, so in solving these type of questions, what do we have to do? First of all, we have to recognize that which probability distribution we should have to use. So in part A, it can be very clearly seen that this is the problem of the negative binomial distribution. Why? Because here we have different successes or different events has taken place, and one of that event has been fixed over some position, such like the sixth person is the fourth one. Okay, so this is what, this is the negative binomial distribution. This last one here, which is part B, is the third person to hear this tale is the first one to believe, means the third person will be the first one who will believe. So that's why the event or trials has to be done unless and until we have get the first person. So that is what, this is basically the geometric probability distribution. Okay, so you have to keep it in your mind. Given data, the given data here we have is the probability that a person will believe is 0.8. so he doesn't believe will be Q, and that is 1 minus 0.8, which is 0.2. Okay, so this is what we have. Now let me solve part A of my question. What do we have to do? Let us again have this hypothetical diagram, okay, in which we have 6 slots. Okay, 1
and these are basically 6. 1 2 3 4 5 6. Okay, and here we have, this is the first, second, third, fourth, fifth, sixth. Okay, here this is the fourth person here who will get what, who will believe it. So this is the fourth person who has the probability of 0.8. okay, so this probability is fixed and these persons are fixed. Okay, all other three, this is the fourth one, so the three remaining will be here, and also two remaining which doesn't believe are also here. Okay, so there can be any combination of them. Okay, so therefore it is 0.8. okay, so all other, any two of them will be here, three of them will be here, so these three of them will be 0.8 multiplied by 0.8 multiplied by 0.8, which will be 0.8 cube, and these other twos will be the person who wouldn't believe, so it would be 0.2 whole square. Okay, so these are here, but this is for only one combination. If you want to find out the other combinations of these five, we have to choose from these five, what we have to choose three which are what, which believe all these things. Okay, so let me make it more concise. So it will be 5 factorial divided by the 3 factorial multiplied by 5 minus 3 is 2 factorial. Okay, multiplying it with 0.2 whole square, and also this one which is 0.8 raised to power 4. So this is what, this is the solution of part A of my question. Okay, so you have understood that this is the negative binomial distribution. In part B of my question, let me solve it here. The third person to hear this tale is the first one to believe. Let me again here this hypothetical diagram. This is 1 2 and 3. This is first, second, third. Okay, the first two person would not believe, so therefore the probability of it would be 0.2 multiplied by 0.2, and the last person would believe, so it would be 0.8, so it would be 0.2 whole square multiplied by 0.8, and that is what, that is basically the solution of part B of my question. Okay, so that's it for today, in which we have seen that how to recognize that certain probability question is of negative binomial distribution problem or geometric probability distribution problem. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.60, and today we are going to discuss the difference between the binomial distribution and Poisson distribution, where to use the Poisson distribution and what are the cases where you can use the binomial distribution. Okay, so let us first go through the statement of this question. The average number of field mice per acre in a 5-acre wheat field is estimated to be 12. Okay, so the average number of mice are given. Find the probability that fewer than 7 field mice are found on a given acre. Okay, so in the first here, let me have here the given data. You can see that here we have to find the fewer than 7 field mice in a given acre, where the average number of mice in an acre are given. Okay, so this is what, this is the lambda or the average number of mice. So wherever you will get this average number of amount and you want to find out some other amount or some other number of amounts, so that is the case where you have to use the Poisson distribution. Okay, so here we have this, and what do we have to find out? In A, we have to find out probability that fewer than 7 field mice are found, or the probability that x is less than 7, which is the similar one as the probability that x is less than or equal to 6. Okay, so here what we can use the formula here as well, which would be exponential of minus lambda of k divided by the k factorial, and then it will be for all the values of 6 or less than 6, so therefore it will be from k equal to 0 up to 6. Okay, this is one method. So it will be what you have to do it all for all the values from 0 to 6 and taking them and then adding them out. Instead of it, we can use a very simple method, and that is basically the use of the Poisson probability table. Let us have it here. So this is the Poisson probability table, and here we can very clearly see that these are all the values for what? These are all the values for the lambda, and these are the values for k or x. Okay, so what is the value of lambda? The value of lambda here is 12. So let me go to 12 here. Okay, so here we have this 12. Okay, this is the column for the 12, and what do we have to do? We have to find the value of x or k which is less than or equal to 6. So therefore it will be here, and let me go through it, and it is the value which we can take, because this is the similar value. You can see here that this is the value we have to find out, and this is the similar formula we have here in this question. Okay, so you can see that this is the similar one, and using this one here and then finding the value, we have found out that this is what? This is 0.0458. Let me write it here, 0.0458, and this is what? This is basically the solution of part A of my question. Okay, this is the solution of part A of my question. Let me move to the part B of my question. In part B, we are asked to find that on a 2 of the next 3 acres inspected, what is the probability that fewer than 7 field mice are found? Okay, so now initially we had this 1 acre. We have found out the probability that x is less than or equal to 6. Now we have what? We have 3 acres. Okay, there are 3 acres. These are 1, 2 and 3. Okay, and we have to find out that in any 2 of the next these 3 acres, okay, what is the probability that 7 field mouse are found? Okay, we have found out the probability of the 1 acre, and what is the probability that 2 of them will have this probability? This is clearly what? This is clearly the problem of the binomial probability. Okay, what do we have to find out? We have to find the probability that x is equal to 2 for from the 3 ones. Okay, so therefore we have to choose 2 from 3. Okay, and then in each the probability of getting this condition is given, and that is here. So this is 0.0458. okay, square, because 2 should have this probability, and the remaining one here is 1 minus 0.0458. okay, so this is what? This is 3 minus 2, which is 1. okay, this is why, because we know that the probability that x is equal to k in binomial probability, that is n choose k, p of k and 1 minus p n minus k. This is for the binomial probability. Okay, so now we have it. Now finding the values of it and then the solution of it, the answer of it would be 0.0060, and that is what? That is basically the solution of part B of my question. Okay, so in this question you have seen that where to use what. In part A we have this average number of mice. From it we have found out the probability that fewer than 7 field mouse are found in a given acre, and the second one, once we have found out this probability, then we had to find out that in the next 3 of them, what is the probability that 2 of them will have fulfilled this condition. Okay, so we have the condition for only 1 acre. If 2 are found, for definite for them we have to use this what? We have to use this binomial probability. Okay, so that's it for today. If you have any question in mind, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.61, and the statement of this question is: suppose that on average 1 person in 1000 makes a numerical error in preparing his or her income tax return. If 10,000 returns are selected at random and examined, find the probability that 6, 7 or 8 of them contain an error. Okay, so now in this question what we have found and what we have is basically the
person in the total number of persons who are making an error. Okay, so from it we can very easily calculate the probability of an error. So what is given from it, we can very easily find out the probability of error, and it would be the number of person who makes the error divided by the total number of persons, which is 1000. So we will get it 0.01. Okay, similarly here, from the samples of 10,000 people, we have to find out that what is the probability that 6, 7 or 8 of them contain an error, which are the documents. Okay, so here we have the samples which are 10,000 which are given here. Okay, so clearly it is what, here we have this, and from it I have to find the documents which contain 6, 7 or 8 error. So clearly it is basically the problem of the binomial probability. Okay, so in binomial probability we have the probability, we have the total number of samples, and we have the number of samples we wanted to find out. So what we can do here, by using the binomial probability, we can very easily do what, in solving it, if I want to find out the probability that x is 6, 7 or 8, I have to find out the probability that x is equal to 6 or x is equal to 7 or x is equal to 8. Okay, so these are what we have to do. But now here, in order to use the formula, what is the formula? We know the formula, which is x equal to k. That would be the n choose k. From it the probability is p, this is k, and 1 minus p and minus k. Okay, so we have to do it for this, and for this. So let us first do it for k is equal to 6. So for x equal to 6, writing all the values, n is 10,000. Okay, so 10,000 here, k is 6. Okay, the probability is 0.01 raised to power 6, and this would be 1 minus 0.01 raised to power 10,000 minus 6. Okay, so from here you can very easily see that this one will give you what, it will be very higher. Okay, this k here is giving you the values, but here you can very easily see that this n is very higher while this p is very small. So in that case, in what we will do, we will find it for this one, for this one, for this one, and with it we have to do a very heavy calculations. Okay, so instead of using the binomial distribution, here this binomial distribution converges to the Poisson distribution. Okay, so this is the case, Poisson distribution or Poisson approximation. Okay, so that is basically the case where any binomial distribution basically converges to the Poisson distribution. Okay, so here in Poisson distribution we have to find it what, this one and this one as well, by using the formula, and the formula here is, for it we will have the formula x is equal to k. For this k we have to find it by exponential of minus lambda raised to the power k divided by the k factorial for all the values of k, 6, 7 and 8 which are given here. Okay, but what is the value of lambda? In order to find the lambda here, lambda is basically the average value. In binomial distribution, in Poisson distribution, the value of lambda is basically np. Okay, here we are given n, here we have here p. So let me write their values. N is 10,000, p is 0.01. so from it we can very easily see that lambda is 10. Okay, so putting the values of lambda here and then solving it, let me solve it here. Okay, so for x equal to k, or for x equal to 6, it will be exponential of minus 10 of 6 divided by 6 factorial for k is equal to 6. Similarly plus exponential of minus 10, which is for lambda, and then lambda raised to power k, which is 7 for here, divided by the 7 factorial plus exponential of minus 10, 10 raised to power 8 for this one, divided by the 8 factorial. Okay, from it we will get the answer by following the approximation and following the formulas we have here. Okay, so this is the second method. The first method was the binomial distribution, which has been approximated into binomial distribution. The third method here is to find it is basically this one, that x is greater or equal to 6 and less than or equal to 8. This basically contains all the values which are 6, 7 and 8. In order to do so, what we can do, we can find it out by x is greater or equal to 8. From it we can subtract all the values which are less than 6. So it would be x is greater or equal to 5. So from it we can find their values and then put them here. Okay, so how to find their values? We can find them very easily by using the Poisson distribution table, which is given here. We have, okay, so this is the Poisson distribution table. Let me move to lambda equal to 10. Okay, and this is what lambda equal to 10. In that we have to find the values at 8 and 5, because x is less than or equal to 5 and less than or equal to 10. So let me find their values. Okay, so at 8 we have the value 0.3328 and at 5 we have value 0.0671. okay, so let me put their values. 0.3328, 0.3328, and here this value will be what? 0.0671, 0.0671. okay, so finding the value of it, the answer of it would 0.2657, and that is what? That is basically the solution of our question which we wanted to find out. Okay, so this is what the answer of it. If you wanted to find it out by using this formula, you would have got the same answer. Okay, this will give you the same answer, this will give you the same answer, but this method is a lot easier than the other two methods. Okay, so that's it for today, in which we have seen the solution of question 5.61. If you have any question, you can ask me in the comment box. See you. Welcome back, guys. This is question 5.62, and the statement of this question is: the probability that a student at a local high school fails the screening test for scoliosis curvature of the spine is known to be 0.04. Of the next 1875 students at the school who are screened for scoliosis, find the probability that A, fewer than 5 fail the test, and B is 8, 9 or 10 fail the test. Okay, so here what is given, let me first write the given data. The probability is given here, which is 0.004, which is here. Okay, similarly the sample size is also given, which is n, and this is 1875. Okay, so on the basis of this, what do we have to find out? Here we want to find out if fewer than 5 fail the test, means the probability that x is less than 5, which is similar as the probability that x is less than or equal to 4. Okay, and also B, the probability that 8, 9 or 10 fail the test, means the probability that x is greater or equal to 8 and less than or equal to 10. Okay, so these are the two probabilities we want to find out. Okay, so now in order to find them out, we have to use what? We can use the binomial distribution as well as the Poisson distribution, but as discussed in the previous section, in these cases where the probability is very low and the sample size is very high, the binomial distribution
approximates into the Poisson distribution, and therefore we have to find the average value of it, which is NP, lambda equal to NP. Let me write here the value of N and P. So the value of N is 1875 multiplied by the P, which is 0.004. Multiplying them together, we will get what? The value of lambda would be 7.5. Okay, so now these are the values we want to find out. This is the value we can find by using the manual method. Okay, the formula for the Poisson distribution is x is equal to k. This is exponential of minus lambda k divided by the k factorial. For them all, we have to use it for 0, 1, 2, 3, 4 and then add them together. Okay, apart from it, what we can use the Poisson CDF table as well. Okay, so let me move to the Poisson CDF table where the value of lambda is 7.5, or the average value is 7.5, and we want to find it for the value of x or k, which is less than or equal to 4. So let me find it out. So this is the table. Okay, in order to find it out, let me have the value of lambda, which is what? Which is basically here. Let me go to 7.5. Okay, the value of lambda is 7.5. Okay, this is 7.5, and we want to find out the value of x, which is less than or equal to 4, which is here. So this value is 0.1321. Okay, and that is what? 0.1321. Okay, so that is basically the solution of part A of my question, where I have written the answer of it by using the tabular method. Similarly, in part B of my question, what do I have to find out? I have to find out the probability that x is greater or equal to 8 and less than or equal to 10. What we can do here again is that we can use this formula for x equal to 8, 9 and 10 and then add them together. Okay, this is one method. The other method is by using the tabular method, and in that method, what do I have to do? I have to use the x is less than or equal to 10, and from it I have to subtract the values for x which are less than or equal to 8. Okay, so I have to use this formula here. Now this and this, both of them can be found out by using the Poisson CDF table as well, which we have seen previously. The value of lambda will remain the same while the value of x will be 10 and 8. Okay, so let me move to the table. So this is 7.5 and we want to find out the value for 10. Okay, so the value for 10 is 0.8622. So it is 0.8622, which is for 10, and for 8 it is 0.6620, 0.6620. Okay, so this is the value for x is probability of x is less than or equal to 10, and this is for probability of x is less than or equal to 8. So subtracting this one from it, what we will get 0.3376. Okay, so this is what we have here. This is 0.3376, and that is what we intend to find out here. Okay, so this we found out the value for this, and the answer we got from them is 0.3376. Okay, so that is basically the solution for question 5.6 to part B. Okay, so that's it for today, in which we have seen the solution of the question which is related to the Poisson distribution. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. This is question 5.63 and 5.64, which are related to the mean and variance of the random variable, which we have discussed previously, and that was related to exercise 5.58 and 5.61. Okay, both of these were related to the Poisson probability distribution. Okay, so before solving these questions, you have to keep in your mind that in Poisson probability distribution, mean is always equal to lambda, okay, which is the average value, and if we know the population value and we know the probability value, we can multiply them together and we get the value of the lambda. Similarly, the value of the variance is also equal to lambda, which is basically the average value here. Okay, so in both of these cases and in Poisson probability distribution, mean and variance both are equal to the average value. Okay, so let us proceed to question 5.63, and the statement of this is find the mean and variance of the random variable x in exercise 5.58 representing the number of hurricanes per year to hit a certain area of the eastern United States. Okay, so in that question, if you have seen the value of, let me solve it, the value of lambda was what? The value of lambda was 6, which are basically the 6 number of hurricanes per year to hit a certain area of the United States. Okay, so therefore here in this question, mean is also equal to 6 and the value of variance is also equal to 6. Okay, this is what this is about question 5.63. In 5.64, we have to find the mean and variance of the random variable x in exercise 5.61 representing the number of persons among 10,000 who makes an error in preparing their income tax returns. Okay, so this was 5.64, and here what we are given here, we are given here the number of samples, which are the 10,000. Okay, so in that question, what you have seen is, if you can look at to the problem which we have previously solved, we have seen that 1 out of 1,000 persons were there, so therefore the probability it had was 0.01. okay, so from it we can very clearly find out the value of lambda, which is np. Okay, let me multiply them. So 10,000 multiplied by 0.01, this is equal to 10, which is also found out in that question as well. Okay, so from it the value of lambda is known, so therefore the value of mean is also 10 and the value of variance is also 10. Okay, so this is the case in terms of question 5.64. okay, so that's it for today, in which we have seen the mean and variance of the Poisson probability distribution. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.65 and 5.66, and the statement of the 5.65 is an automobile manufacturer is concerned about a fault in the braking mechanism of a particular model. The fault can, on rare occasions, can cause a catastrophe at high speed. The distribution of the number of cars per year that will experience the catastrophe is a Poisson random variable with lambda equal to 5. Okay, so on the basis of it, what is the probability that at most 3 cars per year will experience a catastrophe, and B, what is the probability that more than 1 car per year will experience a catastrophe. Okay, so on the basis of this data provided, let us solve this question. Lambda here we have is 5. Okay, and in part B of it, what do we want to find out? What is the probability that at most 3 cars per year will experience a catastrophe? Means I want to find out the probability that x is less than or equal to 3, means at most 3 cars, means all the other values will be less than this one. We want to find out this. And in part B of it, what is the probability that more than 1 car per year will experience a catastrophe, means the probability that x is greater than 1. Both of these probabilities we want to find out. Okay, so first let me solve probability that x is less than or equal to 3. In solving this question, okay, this one, we know that here the formula in the table we have is what? That is the probability that x is less than or equal to small x. Okay, we have something like this one, and we have some value of lambda. On the basis of that lambda value, on the basis of that x value, we can very easily find out the probability of that item. Okay, so here we know the value of small x, we know the value of lambda, which is 5. So let us move to the probability table. Okay, so here this is the probability table, and here let us move to the lambda equal to
what? Lambda equal to 5. So this is the lambda equal to 5, and also the value of x, which is what? Which is 3. So this is the value for it, and this is here. Okay, so we know that the value of it is 0.2650. So it would be 0.2650, and that is what? That is basically the solution of part A of my question. In part B, as this is not in the form of 8, so therefore it can also be written as what? It can be written as 1 minus probability that x is less than or equal to 1. Okay, because here all the values are greater than 1. Here I can write it like this one. So now if I know the value of it, now I know that this is in the form of it. Now you know the value of x, I know the value of lambda, which is a similar one. So by using the probability table, I can find out this value. Okay, so let us move to the probability table, where the value of lambda is still 5 while the value of x is 1. So here it is. So that is 0.0404. So 0.0404. Okay, once I will subtract it from 1, it would be 0.9596, and that is what? That is basically the solution of part B of my question. This is the part A of my question, and all of this is basically the solution of question 5.65. Okay, so that is what? That is basically the solution of question 5.65. So similarly, the question 5.66 is the similar one, and the statement of that question is changes in airport procedures require considerable planning. Arrival rates of aircrafts are important factors that must be taken into account. Suppose small aircraft arrives at a certain airport according to a Poisson process at the rate of 6 per hour. Okay, so lambda is given. Thus, the Poisson parameter for the arrivals over a period of r is mu is equal to 60. Okay, means here the value of, if this is a solution here, okay, so here lambda is what? Lambda is 6. So on the basis of it, part of it is what is the probability that exactly 4 small aircrafts arrive during a 1 hour period. Okay, so part A of it is what is the probability that x is equal to 4. Okay, because exactly 4 arrive during 1 hour period, so therefore this lambda will remain the same. And part B, what is the probability that at least 4 arrive during a 1 hour period. Okay, means, so this is part B, and at least 4 arrive means that all the other values will be greater than 4. So here the probability of x would be greater or equal to 4. Okay, so this is what we have here, but now this is greater or equal to 4. In these type of question, what we can do, we can use the Poisson formula as well, but here it would be feasible for you to use the Poisson table, and that would be in the form of this formula. So therefore I have to convert it into the notation which will be less than or equal to the value of x. So therefore in order to transform it into this formula, what I can write here, I can write it like 1 minus probability that x is now less than or equal to 3. Okay, so these are the values which are now less than this 4. So therefore it will be less than or equal to 3. So here this is the thing which we will find out for part B of my question. Okay, so now let us solve it. Okay, for solving it, let me use this color. So here, in order to solve it, I have to use the formula because it is not in the form of this. So therefore this is a single value. So therefore the formula for it is L exponential of minus lambda of x divided by x factorial. Okay, let me put their values. So it would be exponential of minus 6, which is the value of lambda. Okay, similarly lambda raised to the power 4 divided by the 4 factorial. Okay, solving it, you will get what? You will get the answer of part A of my question. Okay, similarly, so now here, in order to find the probability that x is greater or equal to 4, because the values are here at least 4. Okay, so 4 here, 1 minus probability that x is less than or equal to 3, as this formula is now according to this one. So therefore in order to solve it, what do we have to do? Here the value of x is 3 while the value of lambda is 6. So therefore now I can use the
Poisson distribution table, because now I have all of them in the form of this table. So let us move to the Poisson distribution table where the value of lambda is 6 and the value of x is 3. So let us move to that. So the value of lambda is 6 here and the value of x, which is 3, is here. Okay, because all of this is now in the form, let me show you, in the form of this formula. Okay, where this is what we have transformed it into. Okay, so therefore now in order to find this value, this would be 0.1512. So let me write it, 0.1 minus 0.1512. Okay, so if I will subtract the values from it, we will get the answer from it. Okay, so that is basically the solution of what? This is the solution of part A of my question, and now similarly the solution of part B of my question is this one. Okay, in order to solve the part C of my question, we will do it in our upcoming video. Also you can practice it yourself. Okay, so that's it for today, in which we have discussed the Poisson probability distribution, where to use the Poisson table and where to use the Poisson formula, and the table is basically the Poisson CDF table. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.66, and the statement is: changes in airport procedures require considerable planning. Arrival rates of aircrafts are important factors that must be taken into account. Suppose small aircraft arrives at a certain airport according to a Poisson process at the rate of 6 per hour. Okay, so lambda is given. Thus the Poisson parameter for the arrivals over a period of r is mu is equal to 60. Okay, means here the value of, if this is a solution here, okay, so here lambda is what? Lambda is 6. So on the basis of it, part of it is what is the probability that exactly 4 small aircrafts arrive during a 1 hour period. Okay, so part A of it is what is the probability that x is equal to 4. Okay, because exactly 4 arrive during 1 hour period, so therefore this lambda will remain the same. And part B, what is the probability that at least 4 arrive during a 1 hour period. Okay, means, so this is part B, and at least 4 arrive means that all the other values will be greater than 4. So here the probability of x would be greater or equal to 4. Okay, so this is what we have here, but now this is greater or equal to 4. In these type of question, what we can do, we can use the Poisson formula as well, but here it would be feasible for you to use the Poisson table, and that would be in the form of this formula. So therefore I have to convert it into the notation which will be less than or equal to the value of x. So therefore in order to transform it into this formula, what I can write here, I can write it like 1 minus probability that x is now less than or equal to 3. Okay, so these are the values which are now less than this 4, so therefore it will be less than or equal to 3. So here this is the thing which we will find out for part B of my question. Okay, so now let us solve it. Okay, for solving it, let me use this color. So here, in order to solve it, I have to use the formula because it is not in the form of this, so therefore this is a single value. So therefore the formula for it is L exponential of minus lambda of x divided by x factorial. Okay, let me put their values. So it would be exponential of minus 6, which is the value of lambda. Okay, similarly lambda raised to the power 4 divided by the 4 factorial. Okay, solving it, you will get what? You will get the answer of part A of my question. Okay, similarly, so now here, in order to find the probability that x is greater or equal to 4, because the values are here at least 4. Okay, so 4 here, 1 minus probability that x is less than or equal to 3, as this formula is now according to this one. So therefore in order to solve it, what do we have to do? Here the value of x is 3 while the value of lambda is 6. So therefore now I can use the Poisson distribution table, because now I have all of them in the form of this table. So let us move to the Poisson distribution table where the value of lambda is 6 and the value of x is 3. So let us move to that. So the value of lambda is 6 here and the value of x, which is 3, is here. Okay, because all of this is now in the form, let me show you, in the form of this formula. Okay, where this is what we have transformed it into. Okay, so therefore now in order to find this value, this would be 0.1512. So let me write it, 0.1 minus 0.1512. Okay, so if I will subtract the values from it, we will get the answer from it. Okay, so that is what, that is basically the solution of what, this is the solution of part A of my question, and now similarly the solution of part B of my question is this one. Okay, so in part C of our question, what is the statement? If we define a working day as a 12 hours, what is the probability that at least 75 small aircrafts arrive during a working day? Okay, so this is the statement, and here as the average rate per hour is 6, okay, which is what, which is the lambda. So for 12 hours, what it would be, it would be 6 multiplied by 12. Okay, so the average number of hour here would be 72. Okay, so this is what, this is the lambda. So on the basis of it, what is the probability that at least small aircraft arrive during a working day? So we have to find it out, and this is what we have to find. X is greater or equal to 75, which is a very, very huge number. Lambda is huge, 75 is huge, and in order to find it out, as the limit is now infinite, so what we can do, we can find it out by Px is less than 75. Okay, so we have to use this one. Now this is again a very, very huge number, and in order to use it and in order to solve it, we cannot use the Poisson distribution, but we have to use what? We have to go to the continuous probability distribution, and that is the normal distribution. Okay, so as we know that in Poisson distribution case, as this is a Poisson problem, but due to the very huge number of the lambda and the probability item or the limit of the probability, we have to move to the normal distribution, but the mean will remain the same, and mean would be 72. And as in the Poisson distribution, the mean and variance remains the same, so variance is also 72. Okay, in order to find the value of the standard deviation, the value of standard deviation is square root of 72, because this is the square root of it, and when we will find it out, it would be what? 8.48. Okay, so these are what we have. Now in order to do it by using the normal distribution, we have to use the z-score. Okay, we will also discuss it in our upcoming videos, but what is a z-score? In order to do it, we have to write the 75, and as the value of x is less than 75, so therefore we can write here 74.5, which is the thresholding factor. Okay, from it I have to remove the value of what? Or first I have to remove the value which is the mean value divided by the standard deviation, which is 8.48. okay, this is what? This is z equal to x minus mu divided by the standard deviation. This is the formula I'm going to use. Okay, so this is what we have to do. Now after finding them out, the answer of it or the value of z would be 0.2946. okay, so this is the value, which is the value of z, or the value of z is 0.2946. okay, so we have to find it out for it, and for it the
probability or the value of 8 we want to find out, and it would be 1 minus the probability at which the value is 0.2946. Okay, so we have to find it out. So in order to find this value, what do we have to do? We have a table which is called the z table. Okay, so let us move to the z table and let me find out here the value of 0.2946. so this is z table. Okay, let me see it here, 0.2946. these are all the values here. These are all the values of z, and these are the additive factors. You can see that after the decimal point we have only single item, and these are the additive factors with them. So let us move to 0.29. okay, so this is 0.2, and with it we have 0.29. so if 0.2 is subtracted, the remaining one is 0.09. okay, so the 0.9 is here, so here it would be 0.6141. okay, so this is the value we need to find out. This is the column, this is the row, so 0.6141. so let me write it, 1 minus 0.6141. okay, so after subtracting the value from 1 we will get the answer, and the answer of it would be 0.3859. okay, so that is basically the solution which we wanted to find out here, and that is basically the solution of our question, in which we have used this z score by using this formula, and that's what we have moved from Poisson to continuous normal distribution. okay, so that's it for today, in which we have completed our question 5.66. if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.66, and in our previous video we have solved this question, part A and part B of our question. So in part C of our question, what is the statement? If we define a working day as a 12 hours, what is the probability that at least 75 small aircrafts arrive during a working day? okay, so this is the statement, and here as the average rate per hour is 6, okay, which is the lambda. So for 12 hours, what it would be? It would be 6 multiplied by 12. okay, so the average number of hour here would be 72. okay, so this is the lambda. So on the basis of it, what is the probability that at least small aircraft arrive during a working day? So we have to find it out, and this is what we have to find. X is greater or equal to 75, which is a very huge number. Lambda is huge, 75 is huge, and in order to find it out, as the limit is now infinite, so what we can do, we can find it out by px is less than 75. okay, so we have to use this one. Now this is again a very huge number, and in order to use it and in order to solve it, we cannot use the Poisson distribution, but we have to use what? We have to go to the continuous probability distribution, and that is the normal distribution. okay, so as we know that in Poisson distribution case, as this is a Poisson problem, but due to the very huge number of the lambda and the probability item or the limit of the probability, we have to move to the normal distribution, but the mean will remain the same, and mean would be 72. And as in the Poisson distribution, the mean and variance remains the same, so variance is also 72. okay, in order to find the value of the standard deviation, the value of standard deviation is square root of 72, because this is the square root of it, and when we will find it out, it would be what? 8.48. okay, so these are what we have.
Now, in order to do it by using the normal distribution, we have to use the z-score. Okay, we will also discuss it in our upcoming videos. But what is a z-score? In order to do it, we have to write the 75, and as the value of x is less than 75, so therefore we can write here 74.5, which is the thresholding factor. Okay, from it I have to remove the value of what, or first I have to remove the value which is the mean value divided by the standard deviation, which is 8.48. okay, this is what, this is z equal to x minus mu divided by the standard deviation. This is the formula I'm going to use. Okay, so this is what we have to do. Now, after finding them out, the answer of it, or the value of z, would be 0.2946. okay, so this is the value, which is the value of z, or the value of z is 0.2946. okay, so we have to find it out for it, and for it the probability, or the value of 8 we want to find out, and it would be 1 minus the probability at which the value is 0.2946. okay, so we have to find it out. So in order to find this value, what do we have to do? We have a table which is called the z table. Okay, so let us move to the z table, and let me find out here the value of 0.2946. so this is z table. Okay, let me see it here, 0.2946. these are all the values here. These are all the values of z, and these are the additive factors. You can see that after the decimal point we have only single item, and these are the additive factors with them. So let us move to 0.29. okay, so this is 0.2, and with it we have 0.29. so if 0.2 is subtracted, the remaining one is 0.09. okay, so the 0.9 is here, so here it would be 0.6141. okay, so this is the value we need to find out. This is the column, this is the row, so 0.6141. so let me write it, 1 minus 0.6141. okay, so after subtracting the value from 1, we will get the answer, and the answer of it would be 0.3859. okay, so that is what, that is basically the solution which we wanted to find out here, and that is what, that is basically the solution of our question, in which we have used this z-score by using this formula, and that's what we have moved from Poisson to continuous normal distribution. okay, so that's it for today, in which we have completed our question 5.66. if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.67, and the statement of this question is: the number of customers arriving per hour at a certain automobile service facility is assumed to be follow a Poisson distribution with mean lambda is equal to 7. okay, so this is for a single hour. So part A of this question is: compute the probability that more than 10 customers will arrive in a 2-hour period, and B, what is the mean number of arrivals during a 2-hour period. okay, so one common thing in part A and part B we can see is this 2-hour period, because this is the average number of customers in an 1-hour period, but we have to find it in part A and part B for 2-hour period. okay, so therefore let me first solve part B of my question, and in this part let me solve it, and let me have the other color for it. In this part, this is part B, and in this part, what is the number of arrival during a 2-hour period. okay, for the 1 hour, this is lambda 1 and this is 7. okay, therefore for the nth hour it will be lambda n will be equal to n multiplied by 7. okay, therefore now for a 2-hour period it would be what, it would be lambda 2 equal to the value of n is now 2, so it will be 2 multiplied by 7, so it would be 14. okay, so therefore it is now the average number for 2 hour is now 14. okay, so now on the basis of this we can solve part A of our question. So in part A, what do I have to find out? I have to find the probability that more than 10 customer will arrive in a 2-hour period. Okay, so if X is the number of customer, so X is greater than 10. Okay, so this greater than 10 can be any value from 11 to infinity. So therefore we can simplify it by 1 minus probability that X is less than or equal to 10. Okay, so this is the value. Okay, and also the value of lambda here is 14, the value of X here is this 10. So therefore here for this one I can very easily use the Poisson CDF table, okay, which is given. So in that table what I would do, I will find out the value for X equal to 10 and for lambda equal to 14, and I have to subtract it from 1. So let us go to that table. Okay, so in this table let me move to the value of lambda equal to 14. So this is the value of lambda, which is 14. Okay, and the value of X is 10. Okay, so therefore let me move to the value here. So this is 0.1757. So 0.1757. Okay, and in solving it, the answer of it would be what? 0.8243, and that is what? That is basically the answer of the part A of my question. The answer of part B is given here, and that's what we had to solve in our today's question. Okay, so that's it for today, in which we have seen the solution of question 5.67. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. Today we are going to discuss question 5.68, 5.69 and 5.70 because of the very close relevance between these questions. So what is the statement of question 5.68? Consider exercise 5.62. What is the mean number of students who failed the test? Okay, so what was the statement of question 5.62? The probability that a student at a local high school fails the screening test for scoliosis curvature of the spine is known to be 0.04. Okay, so this is what? This is the probability of the next 1875 students at the school who are screened for scoliosis. Okay, so the next statement of it is of no relevance for us with respect to question 5.68. So here the probability is given, that is 0.04. The sample size here is 1875, which is the P, and which is n, and in order to find the mean number of students who fail the test, here we have to use the formula which is mu equal to np for the Poisson distribution. Okay, we have n, we have p, we can put the values here, and on the basis of it we will find the value of the mean of the number of students who fail the test. Okay, so mu equal to np is the formula which we will use here. If we don't know the value of p, how can we find it out? We can find out by writing the number of the samples in a set which we want to find the probability of, divided by the total number of the items, okay, which are in the sample space. Okay, so this is what, from it we can find out p, and n is what? N is basically the amount in the sample we have here, which is n. Okay, so this is mu equal to np. In most of the cases you will be given the value of p and n, and if it is not given, you can find out by the procedure which I have mentioned here. In question 5.69, the probability that a person will die when he or she contracts a virus is 0.01 of the next 4,000 people infected. What is the mean number who will die? Here again n is given, here this p is given. By using the same formula we can find out the value. So let me find them out. So 4,000 multiplied by 0.001, okay, it would be what? It would be this. Okay, this will be here and it will be 4. Okay, so this is the mean number of the people who will die is 4. Okay, similarly here in 5.62, what was the answer? It was 0.004 multiplied by 1875, and multiplying them we can find the answer of question 5.68. Okay. Now question 5.70. A company purchased large lots of certain kind of electronic devices. A method is used that rejects a lot if two or more defective units are found in a random sample of 100 units. So A, what is the mean number of defective units found in a sample of 100 units if the lot is 1% defective? Here this 1% is what? This is the probability, and from it I can find it out by 1 by 100. This is 0.01. Okay, and the number of items here are n, which are 100. Okay, so this is what n is mu is equal to np. N is 100, this is 0.01, so multiplying 100 with 1 by 100, it will be 1. Okay, similarly the variance of it in the case of the Poisson distribution, mean is almost equal to the sigma square, so therefore the value of the variance will remain the same. Okay, so this is the today's videos in which we have discussed the mean and variance of the Poisson distribution, and I have told you that how to find out the mean value, the cases in which the sample size or the samples are given, which is n, and probability is given, and the other cases in which the probability is not given, the formula to find it out is also mentioned in this video. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.74, and the statement of it is known that 3% of people whose luggage is screened at an airport have questionable objects in their luggage. What is the probability that a string of 15 people pass through screening successfully before an individual is caught with a questionable object? And what is the expected number of people to pass through before an individual is stopped? Okay, so there are basically two parts of this question, and before solving it, let me write the given data. And in the given data, we know that what is the chance of a person which has these luggage screened and have a questionable object is 3%. So the probability of questionable object caught in a luggage is 0.03, and the probability that he will be passed through the airport is q, and let me write it, it will be 1 minus p, so it would be 0.97. okay, means he or she doesn't have a questionable object in his luggage. Okay, so this is what we have. If 15 people have passed through and the 16th one has the questionable object, so what is this? This is basically the geometric probability distribution, because 15 people have passed through and 16th one is the one which has been caught, so this basically indicates the 16th success, okay, or the success at the 16th slot. Okay, so solving it, okay, so solution of it is what I want to find the probability that x is caught which is greater than 15, or the 16th one, it would be what? It would be 1 minus p 15, and the 16th one will be what? It will be the person who has a questionable object in his luggage. Okay, so let me write their values. So it would be 0.97 raised to the power 15, multiplying it with what? Multiplying it with the 0.03. okay, so calculating it and then finding the answer, it would be 0.0191, and that is what? That is basically the solution of first part, which ends here. Okay, so this is what? This is the solution of this question. Now in order to solve the second part of my question, in which what is the expected number of people to pass through before an individual is stopped, so this is what? This is basically related to the expected value of the geometric distribution, and here in order to write the expected value of the geometric distribution, I have a formula that is 1 minus p divided by p. Okay, so let me write their values. So 1 minus p is 0.03 divided by 0.03. okay, so it would be 0.97 divided by 0.03. So calculating it, it will be 32.33, which is almost equal to 32. Okay, so the answer of it is what? The answer of it is 32, and it shows that the expected number of people who passes through before an individual is stopped is 32. Okay, so 32 people will pass. This is the expected value of the people who will pass through once a person with the questionable object is stopped. Okay, so that's it for today, in which we have seen the solution of question 5.74 and seen that how to see that whether certain question is related to the geometric probability distribution or not. Okay, so that's it for today. See you soon. Welcome back, guys. This is question 5.75. And the statement of this question is: computer technology has produced an environment in which robots operate with the use of microprocessors. The probability that a robot fails during any 6-hour shift is 0.10. What is the probability that a robot will operate through at most 5 shifts before it fails? Okay, so the given data here is the probability of failure is, let me call it P. This is 0.1. So it basically says that the probability of the success, which is Q, is 1 minus P, which is 1 minus 0.1. So ultimately this is 0.9. So what do we want to find out? We want to find out the probability that X is what? What is the probability that a robot will operate through at most 5 shifts? Okay, so at most 5 shifts means the maximum number of the shifts here are which will be operated successfully will be 5. So X should be less than or equal to 6. Okay, so if there will be 5 shifts successful, the 6th one will be the what? That will be the failure shift. Okay, so that's why this is basically relevant with the geometric probability distribution. And here, in order to find this one, what do we have to do? We have to write all the values which ranges from 1 to what? To 6. Okay, so therefore here if it is I, so I will be from 1 to 6, and here it would be G, which is for geometric, it will be I, and the probability of failure is 0.1. So therefore writing it here, it would be G1 0.1 or G2 shifts 0.1 or G3 shifts 0.1 or geometric probability of 4 shifts and the failure is 0.1, and also here G5 shifts 0.1 plus G of 6 shifts 0.1. Okay, so let me write their values here. If the first shift is the failure shift, so it will be what? It will be only the failure one, and it would be 0.1. Similarly, if there are 2 shifts and in first shift it works successfully and in the second shift it fails, it will be here, which follows the geometric probability distribution, and here it is. For the 3 shifts, 2 will be the successful ones. Okay, and the last one here would be what? This will be the failure. Similarly, for the 4 shifts, it will be 0.9 are the 3 shifts and 0.1 is what? That is basically the failure shift. Okay, for this one here, it will be 4 shifts which are the success shifts, and this is the failure one, and the last one which is for 6 one. Okay, which are basically the indication of the 5 successful shifts, and the last one is the failure one. So here we would get this one, because the statement, if you read it again, what is the probability that a robot will operate through at most 5 shifts before it fails? So this is the at most condition that it will work through 5 shifts and then it will be failed. Okay, so these are all the conditions which are what? Which basically indicates the failure or the working of the robot when it is less than or equal to 5. Okay, so adding them all together, and first of all let me take the 0.1 common here. It would be 1 plus 0.9 plus 0.9 square plus 0.9 cube plus 0.94 plus 0.9 raised to power 5. Okay, so finding the answer of it, adding them all together and then writing the answer of it, would be 0.4686. okay, so that is basically the solution of the question which we were solving. Okay, so that's it for today, in which we have seen the solution of question 5.75. If you have any question, you can ask me in the comment box. See you soon.